Hi guys, hope you guys are doing well. Hope you guys are studying hard as exams get closer and closer. My name is Daniel. I'm a GCSE and A-level maths tutor, and I've been tutoring for about 6 years now. So today we have the A-level maths Edexcel paper 1 pure mathematics paper. So of June 2023, so last year's paper. And yeah, having done the solutions, I do feel it was a definitely reasonable paper. There were definitely some tricky questions, especially question 15, which you guys will see. You guys will have the timestamps in the description. So if you just want to go to a specific question, then you can do so quite easily. I'll also put the link to the PDF file with all of the written solutions so you guys can have that as well. And yeah, if you find the solutions to the video very helpful and you want to see more, then feel free to just drop a like and subscribe. I'll definitely be doing paper 2 and paper 3, and as well as that, lots of other A-level maths videos as we get closer to the exam. So again, good luck with your exams in the summer, and let's get into it. Okay, so question 1 says we need to find the integral of x to the half multiplied by 2x minus 5 all over 3. And we need to write each term in its simplest form. So with this one, what I would do is, well, straight away, I've got this division of 3 here. Now remember, that is just the same as multiplying by a third, isn't it? So you can actually rewrite the integral as 1/3 x to the power of 1 over 2, and then multiplied by 2x minus 5. And then now we're just going to expand the brackets, aren't we? So we're going to get the third and the 2 make 2/3. So 2/3, and then x to the power of 1/2 plus 1 is going to be 3 over 2. So we get that there. And then we've got 1/3 times 5, which is 5/3. Then we have x to the power of 1/2. Now we're in a position to integrate. So we're just going to add 1 to the power and divide by the new power. So we're going to get 2/3 here. And then x to the power of 1 plus 3 over 2 is 5 over 2. We're going to divide by the new power. And then minus 5 over 3, x to the power of, add 1 to that power, we're going to get 3 over 2, divide by that new power, get 3 over 2 here, plus our constant of integration. Now the question said in its simplest form, so we need to just tidy up all of these fractions here, don't we? So we've got 2/3, and remember that division of 5 over 2 is the same as multiplying by 2 over 5, and then we've got x to the power of 5 over 2 here, minus, and then we've got 5 over 3. That division of 3 over 2 is the same as multiplying by 2 over 3. And we've got x to the power of 3 over 2 plus c. And then now just multiplying the fractions together. 2/3 times 2/5 is going to be 4/15. And then x to the 5 over 2 minus 5/3 times 2/3 is going to be 10/9, isn't it? And then x to the 3 over 2 plus our constant of integration, and we're finished. Okay. So question 2 says f of x is equal to 4x cubed plus 5x squared minus 10x plus 4a, where a is a positive constant. It says given x minus a is a factor of f of x, show that a times by 4a squared plus 5a minus 6 is equal to 0. So from this one here, or this sentence here, if x minus a is a factor, then from the factor theorem, that must mean that f of a is equal to 0. So all you're going to do is just plug in a into your function here and equate it to 0, and then algebraic manipulate it to get this expression here. So let's go ahead and do that. So for f of a, this is equal to 4a cubed plus 5a squared minus 10a plus 4a, and this has to equal 0. So let's just tidy this up a bit. So we're going to get 4a cubed plus 5a squared minus 10 plus 4 is negative 6. So we've got negative 6a here. It's equal to 0. Now let's just factorize out an a. So we're going to get a on the outside, and then 4a squared plus 5a minus 6 is equal to 0 as required. So part A is done, 2 marks in the bag. And then part B says, hence find the value of a and use algebra to find the exact solutions of this equation here. So let's go ahead and do that first. So we've got B here, and then part I. We need to find the value of a. So I'm going to write out the equation where a lies, which is here. I'm going to write out again. I remember the beginning of the question told us that a is positive. So we know that for sure a cannot equal 0. So this is not going to be one of the solutions here. So I'm just going to put no solutions here. Right, no solutions here. And then that must mean it must come from this quadratic here. So we're going to say 4a squared plus 5a minus 6 is equal to 0. Now, you may as well just put this into your quadratic calculator, isn't it? So I'm going to get my calculator here. Let me just zoom out so you can see it a little bit better. And then, yeah, let me just get this here. And we'll go to equals, and we'll go to polynomial. We'll go to degree 2 and then plug this in. So I've got 4, and then I've got 5 here, and then I've got minus 6. And this is 3/4, right? So we got a is equal to 3/4. And then let's just see if there's any others. -2, right? So remember, a was positive, so it has to be 3/4. So you're just going to say since a is greater than 0 from the question, that must mean that a is equal to 3/4. So a is 3/4 is our answer. Now the next one says that we need to use algebra to find the exact solutions of f of x is equal to 3. Now remember, f of x had a in the beginning. We now know what a is. It's 3/4, so we can plug it in to find a complete formula for this function here. So let's go ahead and do that. I'm going to do this on the next page. So I'm going to put b double I, and f of x was equal to, let me just double check, 4x cubed plus 5x squared minus 10x. 4x cubed plus 5x squared minus 10x plus 4a. But remember, we now know that a is equal to 3/4. So if I plug that in here, it's going to be 4x cubed plus 5x squared minus 10x plus 4 lots of a. And remember, we can see that the 4s will just cancel out. So this is just going to be 3. So let me just rub that out and put a 3 here. Okay. Now this is f of x, isn't it? And then in the last part, they told us to solve f of x is equal to 3. So I'm just going to make this equal to 3. And then now, when I solve this here, this will give us, we move the 3's over, and they will cancel, won't they? So this will just give us 4x cubed plus 5x squared minus 10x is equal to 0. And then here, this is just a cubic, isn't it? So you can just put this into your calculator. So you may as well go ahead and do that. So let me just go back here. And it's a cubic, isn't it? So we're going to go to polynomial. We're going to go to degree 3 and then plug in the coefficients. So I've got 4, I've got 5, I've got minus 10, and I've got 0 for the constant term, isn't it? So I'm going to put 0 here. And then we see that we get one value of x is equal to minus 5 plus the square root of 185. And that was all over 8, isn't it? So let me just double check that there. Yeah, that's fine. And then if I click equals again, well, I get the negative one. So it's going to be plus or minus. And then let me just get the last one by pressing equals. It's going to be 0, isn't it? So these are our solutions here. Two solutions here, plus or minus of minus 5 plus root 185 over 8. And the other one is x equals 0. So this is our final answer, and we're finished. Okay. So question 3 says, relative to a fixed origin O, the point A has position vector 5i plus 3j plus 2k. The point B has position vector 2i plus 4j plus ak, where a is a positive integer, right? And it says for part A, show that the magnitude of O to A is the square root of 38. Okay, that's pretty fine. It's pretty easy. So you're just going to take the magnitude of O to A, and that just means just doing Pythagoras with the components. So I'm going to take the square root of the components of A, which are 5 squared plus 3 squared plus 2 squared. And then let's work all of this out. So 5 squared is 25, 3 squared is 9, 2 squared is 4. 25 plus 9 is 34, 34 plus 4 is equal to 38. So therefore it's the square root of 38 as required. So that's part A done. Now, part B says, find the smallest value of A for which the magnitude of O to B is greater than the magnitude of O to A. Okay, so we need the magnitude of O to B, and this is greater than the magnitude of O to A. Now, the magnitude of O to A is what we've just calculated in part A. So I'm going to put this on the right hand side of the inequality. So root 38 here. And then the magnitude of O to B would just be the exact same thing we did in part A with the components of B. So it's going to be 2, 4, and A. So it's going to be just 2 squared plus 4 squared plus A squared. So we need to figure out the smallest value of A for which this inequality holds. So that's not too bad. Let's figure out, or let's simplify the third a bit. So we've got 4 plus 16 plus A squared, and this has to be greater than the square root of 38. And then 4 plus 16 is 20. So it's 20 plus a squared is greater than the square root of 38. And then obviously we've got surds on both sides. We can just square both sides, can't we? So we're going to get 20 plus a squared is greater than 38. And obviously if that's the case, then that must mean that a squared has to be greater than 38 take 20, which is 18. Just move that 20 over to the right. And then obviously if a squared is greater than 18, what must a be greater than? That will just be the square root of 18, isn't it? So what we can do here is let's figure out what that actually is. Let's get our calculator, plug that in. So root 18 is 3 root 2 as a surd, but that's no use. We need it as an actual decimal to see what the actual number is. So fine, we know that a is equal to, we know that the root 18 is 4.24, blah, blah, blah. So I'm going to say a has to be greater than approximately 4.24. So this is what has to be true for this inequality to hold. And remember, we need the smallest value of a, and we know that a is a positive integer. So if a has to be greater than 4.24 and has to be an integer, well, the smallest one will be the next integer after 4.24, which is 5. So therefore, we could just say a is equal to 5, and then you could just write smallest integer. Smallest integer. And that's it. Okay. Question 4 says the curve C has y equals f of x, where x is an element of the rules. Given that f dash of x is equal to 2x plus a half cos x, the curve has a stationary point with x coordinate alpha. Alpha is small. Use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. Okay, so remember, the first thing that you want to do is write out your small angle approximation for cos, because that's what we're dealing with. And that states that if we have cos theta, then this is approximately 1 minus theta squared over 2, isn't it? For small values in radians, right? Now they've told us that f dash of x is equal to 2x plus a half cos x, right? And the curve has a stationary point with x coordinate alpha. So in other words, that means that f dash of alpha must equal 0, isn't it, if there's a stationary point there. So what you want to do is just plug in alpha into your expression for f dash of x. So that's just going to be f dash of alpha is equal to 2 alpha plus a half cos alpha, isn't it? And this is equal to 0, right? Now, since we know alpha is small and they've asked us to use the small angle approximation for cosine, you're going to change this here, aren't you? So then you're just going to get 2 alpha plus 1 half. And instead of writing cos alpha, you're going to write the small angle approximation for it, which is 1 minus alpha squared over 2. Right, we're using alpha because it's in terms of alpha. This is equal to 0. Now they've asked us to find an estimate for alpha, so we just need to solve this equation here. So let's go ahead and do that. So doing that, we're going to expand this bracket. So we're going to get 2 alpha plus a half minus alpha squared over 4, isn't it? And this is equal to 0. Now let's just tidy this up a little bit. I'm going to times by 4. So I'm going to have 8 alpha plus 2 minus alpha squared is equal to 0. Now, if I move everything from the left to the right, this will give me 0 is equal to alpha squared. And then I'm going to move this 8 alpha next. So it's going to be minus 8 alpha and then minus 2 here. Just to get into it, just to get it into the form of a quadratic. And because we have a 0 on the left, I can just put this on the other side, can't I? And just say this is equal to 0. So now we're just solving this. So what we're going to do is just get the calculator. So getting that up, let's just see what we get. Let me just zoom out a bit so we have it here. And then solving this, just going to put this into the quadratic calculator function. Go this here, and then polynomial, and I'm going to go to degree 2. Put the coefficients in. We've got 1, we've got minus 8, and we've got minus 2. Plugging this in, we get alpha is equal to 4 plus 3 root 2, which is 8.242 blah blah blah. Now this is too large, isn't it? Right? Because remember, alpha has to be small, right? Because we're using a small angle approximation, so it can't be this solution. Gonna click equals. We get 4 minus 3 root 2, and that is definitely more like it, isn't it? Because that's very close to 0. in comparison to the other one. So we're going to say alpha is equal to, and then that number there is minus 0.242, blah, blah, blah. And they wanted it to 3 decimal places. So it's going to be alpha is equal to minus 0.24, and I think that is 3. So this is our answer here, and this will give you 3 marks. So that part is done. And then now, part B says that the point P03 lies on C. And for 2 marks, we need to find an equation of the tangent to the curve at P, given answer in the form y equals mx plus c, where m and c are constants to be found. Now remember how we find the equation of a tangent. We need to figure out what the gradient is at that point, and you just plug it into your derivative, isn't it? Your function for dy dx or f dash of x, whatever notation you're using. So we know that we've got f dash of x is 2x plus a half cos x. So I'm going to write this out here again. I'm going to do it on this page. So for part B, we know that f dash of x is equal to 2x plus a half cos x. Now, we know that the point P is 0, 3. So we need to find the gradient at that point. Point B is 0, 3. So let's plug in x equals 0, shall we? So we're going to get 2 lots of 0 plus 1/2 times the cosine of 0, isn't it? Now, this is just 0 here. The cosine of 0 is 1, isn't it? Right? So we're going to have this here, and this is just equal to 1/2, isn't it? So we get this here for the gradient of the tangent at this point 0, 3. Now remember the equation of a tangent, formula is y minus y1 is equal to mx minus x1, and we've got everything that we need, don't we? So we've got the gradient of 1/2, and we've got the point P, which was 0, 3. So let's plug in everything and see what we get. So we're going to get y minus 3 is equal to m, which is a half, and then x minus x1, which is just 0. So I'm just going to put x here. And then now tidying this up, this will just give us y is equal to 1/2 x plus 3. And this is your answer. And I think they asked for the form y equals mx plus c. Yeah, so we're fine. This is our answer. Finished. Okay. So question 5 says, a continuous curve has equation y equals f of x. The table shows corresponding values of x and y for this curve, where a and b are constants. And we've got the table of x values and then the corresponding y values underneath. The trapezium rule is used with all the y values in the table to find an approximate area under the curve between x equals 3 and x equals 4. Given that this area is 17.59, show that a plus 2b is equal to 51. Okay, so all we're doing with part A is just using the formula for the trapezium rule and equating it to 17.59 and just doing a little bit of algebra to get the result that they want in part A. So let's go ahead and do that. So let's just remind ourselves of the trapezium rule, which states if I have an integral of f of x, and this is between two limits, and in our case, we're integrating between 3 and 4, aren't we? So I'm going to use 3 and 4. Then this is just going to equal 1/2 multiplied by h, and then this is multiplied by the first y value plus 2 lots of all of the middle y values, n minus 1, and then we add the last y value at the end. So we're just going to apply this with the table at hand. So let's figure out what h is first. So we know that h is equal to b minus a divided by n, isn't it? Now, b and a are the limits, so I've got 4 take 3, and then n is the number of strips. So let's just see how many strips we have. We've got 1 here, we've got another one here, 2, we've got 3, we've got 4, and there's 5. There's 5 strips altogether, so n is 5. So therefore, we've got this here, 4 take 3 is 1, and we've got a 5 on the bottom, so it's just 1/5. So now we can say we've got 1/2, and then we've got h, or not h actually, because I know what h is, times 1/5. And then we're going to plug in the y value. So the first y value is a, so I'm going to put that there, and then plus 2 lots of all of the middle ones, which is going to be 16.8 plus b plus 20.2 and 18.7. So 16 points, let me just read 16.8 plus b, 16.8 plus b plus the other two, which are 20.2 and 18.7, 20.2 and 18.7. And then we're going to add on the last one, which is 13.5. 13.5. And this here is equal to 17.59, isn't it? So we just need to tidy this up and use algebra to get what they want. So let me just move this here. Let me move the equal sign. let me get the equal sign and move it here. Move this equal sign here, and then let me move this over a bit to the left here. So we've got this here. And this is equal to 17.59. So we're just going to tidy everything up. So what I'm going to do is I'm just going to work out what these are here, just to make life a bit easier for ourselves. So let me get my calculator out. Let me just zoom out so you can see. So I've got a bit of room. So now let's just put this in here. Oops, this here. So we're going to have 16.8 plus 20.2 plus 18.7. And this is equal to 55.7, isn't it? So we could say, well, this is 1/10 anyway. Forgot the pen. This is 1/10. And then we've got A, and then the calculator still showing this. It is. Let me just get rid of it. So it's going to be A plus 2 lots of, and then I've got a B here. That's going to be B plus 55.7, isn't it? And we've got plus 13.5. And then this is equal to 17.59 still. And to be honest, what I'm going to do actually is I'm going to multiply through by 10 anyway, right? Because I'm going to do it anyway. I'm going to need to do it at some point. So I'm going to multiply through by 10. That will just give me A plus 2B plus, and then let me just expand that bracket. So I've got 2 times 55.7. This is equal to 111.4. 111.4 plus the 13.5, right? And this is equal to, so remember, just so I don't skip steps, this is still 1/10, like this. All I've done now is just tidied up the inside. Now, if I times through by 10, then I'm just going to have 175.9 on this side, and then that will just disappear. So I'll just be left with this 2b plus that 0.4 and 13.5. So now we're nearly done. So now just tidying up that last bit. So let me just get my calculator again. Okay, it's still there. So it will be 111.4 plus the 13.5. So plus the 13.5. This gives me 124.9, isn't it? So I've got A plus 2B is equal to 1, 2, sorry, not equal to, not yet, plus 124.9. This is equal to 175.9, isn't it? And then we're just going to move that over. So I've got 175.9, and then I'm going to take away 124.9, and this gives me 51. So therefore we get A plus 2B is equal to 51 as required, and that will give you the 3 marks in part A. Now part B, it says given also that the sum of all the y values in the table is 97.2, find the value of A and the value of B. So this is just a simultaneous equation, isn't it? So let's go ahead and sum all of the y values and then make it equal to 97.2, see what we get. So what I'll do actually, let me just screenshot the lower table so I have it underneath. So if you just give me a sec. So I'll just screenshot this here. Okay. And if I paste it here now, just so I have those values, so I don't have to keep going up and down. So I've got this here. And we're going to add all of these together, aren't we? So adding these all together, it's going to give me A plus 16.8 plus B plus 20.2 plus 18.7 plus 13.5, right? And this is equal to 97.2, I believe. Let me just double check. Yeah, that is correct. So now let's just tidy this up here. So let's do the numbers. So where's my calculator? Yeah, there you are. So it's going to be, let me just do this here. So 16.8 plus 20.2 plus 18.7 plus 13.5. This gives me 69.2, doesn't it? So I've got A plus B plus 69.2 is equal to 97.2. Then if I move the 69.2 over, that's just 97 minus 69, isn't it, essentially, which is 28. So therefore, I've got A plus B is equal to 28 for the second equation. So let's get the first equation up again, which was A plus 2B is equal to 51. So yeah, that's fine. So I'll do it here. So A plus 2B is equal to 51, equation 1. And then A plus B is equal to 28. Now, if I take those away from each other, then the a's will cancel. This will just be b, and then 51 take away 28 would be 31, 23, isn't it? 23. So b is equal to 23. And then now we just find out what our a is, and that's quite easy because plugging it into there, we're going to have a plus 23 is equal to 28. So therefore, a is equal to 5. So a is equal to 5 and b is equal to 23. And that will give you the remaining 3 marks in this question. And that's 6 marks in the bag. So we're done. Okay, so question 6 says a is equal to log with base 2 of x and b is equal to log with base 2x plus 8. And then it says expressed in terms of a and slash or b, these three here. So the first one is part A, which is log of base 2 of root x. So essentially with these types of questions, you're just trying to manipulate algebraically to get these expressions somehow, right? So with this one, remember, we know from our power rule that I can write the root x as x to the power of 1/2. And from our log rules, we know that the power can drop to the front. So it becomes 1/2 log base 2 of x. And then we have exactly what we've got in the questionnaire. This is equal to a. So therefore, this is just 1/2 a. That's the first part done. Then part B, we've got log of base 2 of x squared plus 8x. Now, when I look at this, I can see, well, inside, I've got a common factor of x. So what I would do is I'll just factorize and then see what happens. If I take out an x, I'll have x and then x plus 8. And then from our log laws, we know that when we have a product of anything inside, we can just split them into a sum, can't we? So I'm going to do it here. So this will just be log of base 2 of x plus log of base 2 of x plus 8, wouldn't it? And we know that from the question, log of base 2 of x is just a, and the other one is just b. So therefore, this is just a plus b. So that one is done. And then part C is a little bit more tricky. So we've got log of base 2 of 8 plus 64 over x, isn't it? Okay, so let's look inside and see what we can do. So what I would do first is I would write this as I'll write them with the same denominator, right? So I could combine the fractions. So it becomes this is going to be 8x divided by x, and then this is still 64 over x. And then we're going to combine them because they've got the same denominator now. So this will just become 8x plus 64 all over x, isn't it? Okay. And what can I do from here? Well, we've created a division, so we know that we can subtract the numerator and the denominator using our log law. So this is just going to become 2, and then 8x plus 64 minus the log of base 2 of x. And remember, this is a, isn't it? This is a. So we can just write this as so far. We can write log of base 2 of 8x plus 64 take away a. So remember, we're just trying to get it all in terms of a and b, right? So now I need to look at this. Now, if I look here, well, again, I can take out an 8. So I will go ahead and do that. That will give me x plus 8 here. And remember, this is still minus 8. Now, remember, we have a product again, just like we did in part B. We can split this into a sum. So it becomes log of base 2 over 8 plus log of base 2 of just x plus 8. And we're still taking away a. Now remember, from the question, we know that log of base 2 of x plus 8 is just b. So therefore, I can replace this here with a b. So it's b minus a so far. And what's left is just to sort this out. Now remember, 8 is the same as 2 cubed. So I can write this as log of 2 cubed. And then from our power rule, we know that that 3 can drop to the front. So it becomes 3 of log 2 base 2 of 2 plus b minus a. And we know from our log laws, when we have log of base a of a, so the same thing here, this is always equal to 1, isn't it? So this is just 3 times 1. So therefore, the final answer is 3 plus b minus a. And we're done. Okay, so question 7 says, the function f is defined by f of x is equal to 3 plus root x minus 2, where x is an element of the reals and x is greater than 2. Part A says that we need to state the range of f. So let me write this equation again. So f of x is equal to 3 plus root x minus 2, right? We know that x is greater than 2, so let's not forget that. Now, what I like to do when I'm trying to find the range of a function is to sketch it, to see what the graph looks like, so I can clearly see what the range would be. So what I would do with this one is I would actually sketch the original graph, which is root x, isn't it? Because this is just a transformation of that. So the graph of root x looks like this, right? Now, we want to build up and get this graph here. So the first thing I'm going to do is apply that -2. And we know from our graph transformations, that's just going to shift it 2 units horizontally. So therefore, it will be here. Now, right now, we can see that the minimum point is on the x-axis. So far, the range is just f of x is greater than or equal to 0, isn't it? Now, if I want to get this +3, well, that means I have to shift it 3 units upwards, isn't it? This +3 would shift the graph 3 units vertically. So I'm going to bring it up here, right? So that would mean that the new minimum point is going to be here, isn't it? And this is y is equal to 3. So therefore, the range of our function here, right? f of x is equal to 3 plus root x minus 2. The range, right, is going to be f of x is greater or equal to 3. Now, you have to be very, very careful here, because you have to look at the domain. The domain states that x is greater than 2. So we would include 3 in our range if we could plug in x equals 2, because that would give us 3 in this formula here. However, since x equals 2 is not part of our domain, we can't get a value of 3 out. So therefore, your final answer for the range would just be f of x is greater than 3. And that will be your answer for part A. And now let's have a go at part B. So part B just says we need to find the inverse. So let's do that. That's not too bad. So part B, we know that f of x is equal to 3 plus root x minus 2. I'm going to change this to a y. 3 plus root x minus 2. I'm going to swap x and y around. So it's going to be x is equal to 3 plus the square root of y minus 2. And then to get the inverse, we're just going to rearrange to make y the subject. So I'm going to take 3 away from both sides. So root y minus 2. And then we'll do the rest here. So I'm going to square both sides now. So I get x minus 3 all squared is equal to y minus 2. And that tells me that I've got x minus 3 all squared plus 2 is equal to y. And then once you've made y the subject, you're just going to replace it with the inverse. So you're going to have the inverse of f is equal to x minus 3 squared plus 2. And just as a habit, always write the domain, because you may need it. So remember, the domain of the inverse is going to be the range of the original function. The range of the original function was f of x is greater than 3. So the domain of this inverse is just going to be x greater than 3. So this here will be your answer for part B. Now that one's done. Let's go to the next one. Part C tells us that the function g is defined by g of x is equal to 15 over x minus 3, where x is an element of the rules and x cannot equal 3. And we need to find g of f of 6. Okay, so I'm going to do it here. I'm going to write out the functions that we have. So g of x was equal to 15 over x minus 3. And f of x, we already know, was equal to 3 plus root x minus 2. And the question is asking us to figure out what g of f of 6 is. So let's plug in let's plug in 6 into f of x. So let me just plug this here. So in that case, that's just going to be f of 6 is equal to 3 plus square root of 6 minus 2, which is the same as 3 plus the square root of 4, which is the same as 3 plus 2, which is equal to 5. So f of 6 is 5, and then we're going to plug in 5 into g of x to get g of f of x. So we can say g of f of 6 is just going to equal 15 over 5 take 3, which is just 15 over 2. So that one is done. And then part D, let me just get this here. Part D says we need to find the exact value of the constant. Is that alpha or A? Doesn't matter. I'll just call it alpha. For which f of alpha squared plus 2 is equal to g of alpha, right? So let me write that here. We've got f of alpha squared plus 2 is equal to g of alpha. Now, to answer this question or to solve it, well, let's just plug this into our formula here. So remember, we know that f of x is equal to 3 plus the square root of x minus 2. So f of alpha squared plus 2 is going to equal 3 plus, and then we're just going to replace, remember, with a function. This is the input. So this is the input here. So if this is not the input, then it's just going to be over here, isn't it? Right? So we're just going to get alpha squared. Whoops, where's my pen? Alpha squared plus 2 and then minus 2. Now tidying that up, we're going to get 3 plus, the 2's will cancel. So it's just going to be alpha squared here. And then that will just cancel to give me 3, isn't it? So sorry, a. So it's going to be 3 plus a. So we know that f of alpha squared plus 2 is just equal to 3 plus a. And we need to equate this to g of a. Now remember, g of x was just 15 over x minus 3. So we know that g of alpha is just equal to 15 over alpha minus 3. So now we can equate the two together, equate these two. And I'll do it here. This will give us 3 plus alpha is equal to 15 over alpha take 3. If I times both sides by alpha minus 3, then I'll get 3 plus alpha, and then alpha minus 3 is equal to 15. Now solving this, this is just the difference of two squares, isn't it? So when I expand this, I'm just going to swap these around. So it's going to be alpha plus 3, and then alpha minus 3 is equal to 15. And then this is quite clear to see this is a difference of two squares. So this would just give me alpha squared minus 9, wouldn't it? And you could just expand it normally if you want, just to check. But anyways, let's move the 9 over. So we're going to get alpha squared is equal to 24. So that means that alpha is just equal to plus or minus root 24, isn't it? And then it says the exact value or value. It says value, so we need 1. Now let's just simplify this third. So we get plus or minus, and then this is going to be 4 times 6. So this is going to be plus or minus root 4 root 6, which is going to be plus or minus 2 root 6. Now we need one of them, don't we? So which one do we pick? I'm going to assume it's the positive one, but let's just make sure we know why it's the positive one. Yeah, when we plug in, where's our function? Oh yeah, of course. So we know that this is our expression here, f of alpha squared plus 2, right? And we have a restriction on its domain. So technically speaking, if this is our input, f of x, we know that x has to be greater than 2. So in our case, this is our input here. This has to be greater than 2 as well. So we could say from here, alpha squared plus 2 has to be greater than 2. If I take 2 to the other side, that means alpha squared is greater than 0. So that means that alpha is greater than 0. So that tells me that alpha has to be positive. So I have to pick the positive solution. So for sure, the final answer is just alpha is equal to 2 root 6. We're done. Okay, so question 8 says, figure 1 shows the plan view of a stage. The plan view shows two congruent triangles, ABO and GFO, joined to a sector OCDEO of a circle center O, where angle COE is 2.3 radians, the arc length is CDE, which is 27.6 meters, and AOG is a straight line of length 15 meters. Part A says that we need to show OC is equal to 12 meters for 2 marks. So what I'm going to do is I'm just going to get that diagram here again, and I'm just going to paste it here just so we can refer to it and we don't have to keep going up and down. So we need to show, oops, where's it gone? Where's it gone? Okay, we're over here. We need to show that O to C is equal to 12. And we can see clearly that O to C is just the radius of that sector. So I'm going to call it R. And we know that the arc length is 27.6 because they told us, and it's even labeled as well. And this angle here is 2.3 radians. So I'm going to label this theta, I'm going to label this L, and we can see quite clearly we can just use the arc length formula, can't we? L equals R theta. And we know that L is equal to 27.6, and R is what we're trying to find, and theta is 2.3 radians. So that must mean that 27.6 divided by 2.3 is equal to R. So we're going to plug this into the calculator, and we should hope to get 12, isn't it? So let me just get my calculator. I'll zoom out so you can see it a bit. Yeah. So now putting this in, we're going to have 27.6 divided by 2.3. And this gives us 12. So we know that this works. So I'm going to say R is equal to 12 or OC because that's what they're using, isn't it? OC. So that's fine. That works. Okay. So that part A is done. Part B says, let me just get rid of the calculator. Show that the size of angle AOB is 0.421 radians, correct to 3 decimal places. So I'm going to get this diagram again one more time. So copy this diagram. I'm going to paste it on the outside. And then bring it here. We need to show that the angle AOB is 0.421. So remember, angle AOB is this angle right here. And we know that these two triangles are congruent because they told us that must mean that this angle is also the same. Now, they also told us that AOG is a straight line. We know that angles in a straight line add up to 180 when we're in degrees, but since we're in radians, they're going to add up to pi. So to work out this angle here, angle AOB, well, we know it's just going to be equal to, let me just put this in blue, it's going to be 180 in degrees, but pi in this case because we're in radians. Take away this angle in the middle, which is 2.3, and then we're going to half it because the angles here are the same. So I'm going to put this into my calculator and see what it gives us. This is going to give us pi here, pi, and then minus 2.3 over 2. This gives us 0.4207 blah, blah, blah. To 3 decimal places, though, that is 0.421. So that is done. Let me just write 0.421 here as required. So that's part A and B done. So that's great. Now let's go to part C, which is 6 marks, I believe. Now, what does it say? It says, given that the total length of the front of the stage, B, C, D, E, F, is 35 meters, find the total area of the stage, giving your answer to the nearest square meter. Okay, so let me get this diagram one more time. And I'll paste it here. And what I'll do actually is I'm going to get the question as well. So the part C, just so we have everything we need. So we don't need to keep going up and down. So let me put this here. So crop that question. And I'm going to paste it here. Paste it here. And then we've got it here. And then let me just bring it here. And then let me just make it a bit smaller so we can just fit it into the frame. Okay. So given that the total length of the front of the stage, B, C, D, E, F is 35 meters, we need to find the total area, right? Giving your answer to the nearest square meter. Okay, so the answer is just going to be the area of this one, plus the area of this one, plus the area of this one. Now, what do we know? Well, we can work out the area of the sector quite easily, can't we? Because remember, we know that the radius is 12 because we were asked to show that in part A. So this is 12 here. So if I want the area of number 1, right? Well, this is just going to be equal to half r squared theta, isn't it? And I'm going to call this area of the sector OCDEO. OCDEO. And then plug in everything that we know here. It's going to be 1/2. The radius is 12, so 12 squared. And then the angle in question is 2.3 radians. So I'm going to put this into the calculator. Just zoom up a bit so you can see the calculator when I get it. And this here will be 1/2, 1/2, and then I need a 12 squared, so I'm going to just say times by 12 squared, and then times by 2.3. This is 165.6, isn't it? So 165.6 meters squared. And I'm just going to leave that for now, right? Because that's just part of our answer. It's not the entire thing, but it's useful to have it. So now we've got the area of that sector, so we can leave that. Now, part C did tell us that the total length of the front of the stage B, C, D, E, F is 35 meters. And let's highlight what part that is referring to. So this is this part here, this part, and this part. This is all 35 meters. Okay, now we know that the middle part is 27.6, the arc, and we know that the two triangles are congruent. So for sure, we know that this here, B to C, and E to F have to be the same distance. So to work out what they are, that's quite easy, isn't it? Because I'm just going to put this here. We can say that E to F then is going to equal the entire thing, which we know is 35. We're going to take that 27.6 away. We're going to half it, aren't we? So I'll put this into my calculator and see what it gives us. Putting this in. This will give us 35 minus 27.6 divided by 2. And this is equal to 3.7. So we now know the length of the two green parts of this stage, don't we? So they're both 3.7. So I'm going to label these here. These are 3.7. This is 3.7 here. This is 3.7 here. Now, how does that help us? We need to calculate the areas of these triangles. So it's definitely trig that we need to do. Now, what do we know about these triangles? Well, in part B, we were able to show that this angle here was 0.421. So this is 0.421. I remember they told us that AOG is a straight line, and since these two triangles are congruent, it must mean that A to O is the exact same length as O to G, which is just going to be half of 15, which is going to be 7.5. 7.5, right? So now, what can we do here? Well, we're in a position to calculate the area here. So let me just get this diagram. I'm going to draw this diagram out again, just so it's a bit clear for us to see what's going on here. So if I draw that diagram again, ABO, so it's going to look like this, isn't it? Something like this, like that. And then what do we know about this? This is A, this is B, this is O. We know that A to O is 7.5 meters. We know that the angle inside is 0.421. And we know that B to O is going to be the BC 3.7 plus the radius, which is 12, which is just 15.7, isn't it? So now we're in a position because we can just use half AB sine C because we've got two sides and the angle in between. So we can set the area of triangle ABO. We can just use the formula half AB sine C, can't we? So plug in everything that we know, half, and then A and B are just going to be the two sides, doesn't matter which way you put them. So we're going to put 7.5 here, and then 15.7 here. And then sine of the angle, which is 0.421. So I'm going to plug this into the calculator and see what it gives me. Let me just zoom out a bit again so you can see the calculator when I get it. So now, plugging this in, it's going to be 1/2 multiplied by 7.5 and 15.7. And then sine of that angle, isn't it? So sine of 0.421. And this is equal to 24.0606, isn't it? So I'm going to write 24.0606 dot dot dot. Now, remember, this is just one of the triangles. The two triangles are congruent. So I just need to double it, isn't it, to get the area of both triangles. So I'm going to times it by 2. Times it by 2. Get my calculator again. I'm going to times it by 2. This gives me 48.1212 blah, blah, blah. So this will give me 48.1212 blah, blah, blah. And this is the area of both of the triangles, isn't it? So I'm just going to write area of the two triangles. So now we're in a position to answer the question. The question asks us for the total area of the stage. We know that the area of the stage is the area of the two triangles plus the area of the sector. We have all of that now. So we can select the final answer then is just going to be, right, this here. It's going to be total area will equal the 48.1212 dot 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 plus the area of the sector, which is 165.6. 165.6. So I'm just going to put this into my calculator and see what it gives me. This will give me, I'm going to put answer here and then 165.6. And this is 213.721. The question asks us to give our answer to the nearest meter, right? Nearest meter squared. So it's going to be 214, isn't it? Oops. 214 meters squared. And we're done. Answer finished. Brilliant. Okay, question 9 says the first three terms of a geometric sequence are 3k plus 4, 12 minus 3k, and k plus 16, where k is a constant. Part A says that we need to show that k satisfies the equation 3k squared minus 62k plus 40 is equal to 0. So, okay, this comes up quite a lot, right? Whenever you see a geometric sequence and you've got the first couple of terms expressed algebraically, and they ask you to form some sort of equation or show that a certain equation satisfies blah blah blah, what you always want to do is find expressions for the common ratio. Right now, remember, the common ratio of a geometric sequence is always defined as one of the terms divided by the term before it. So if I use the first two terms here, we can say that the common ratio is just gonna be 12 minus 3k, and we're gonna divide this by 3k plus 4. And because the common ratio stays the same throughout the sequence, I can do the exact same thing with the third and the second term, and I know it has to equal this expression here. So if I do that again, then it will be k plus 16 over 12 minus 3k. And this is going to be times by r, and then we're going to times by r, isn't it, to keep going. Anyways, so we've got two expressions for the same thing, right? The common ratio, so we can make them equal to each other, can't we? So let me just zoom in a bit, and then we'll do this here. So this will give us 12 minus 3k over 3k plus 4. This will equal k plus 16 over 12 minus 3k. Now we need to cross multiply to get it into the quadratic that they want. So we're going to have 12 minus 3k here, and then another 12 minus 3k here. And this is equal to k plus 16. And then we've got 3k plus 4. And let's expand and simplify. So 12 and the 12 will make 144. So 144 here. And then we've got, that's minus 36k. Then we've got another one here, minus 36k again. Forgot the 6, minus 36k again. And then we've got negative 3 plus, negative 3 times negative 3 is positive 9. So it's going to be plus 9k squared, isn't it? And this is equal to k and a 3k will make a 3k squared. And then plus k and the 4 make a 4k. And then 16 and a 3 makes a 48. So that's going to be 48k, huh? And then we've got 16 times 4, which is 64, isn't it? So we've got this here. Let's tidy up the left and the right hand side. So the left hand side will give us 144. Minus 36 minus number 36 will give us negative 72. Negative 72k plus 9k squared. And this is equal to 3k squared. And 4 plus a 48 is just 52. So 52k. And then plus 64. Now we're going to tidy this up. Let's move everything from the left to the right. So if I just start with the k squared terms, I've got 9k squared here. Take away 3k squared. That will give us 6k squared. And then we've got, for the k's, we've got 72k, minus 72k, sorry. And then we're going to take away 52 away from that. So that's just going to be 100, and that's going to be negative 124k, isn't it? And then the constant terms, I've got 144 on the left. I'm going to take away 64. That's just going to give us 80. So I get plus 80 here is equal to 0. Now let's remind ourselves with what they wanted. They wanted 3k squared, isn't it? So we just have to divide by 2, don't we? So we get 3k squared here. And then half of 124 is 62. So it's going to be minus 62k here. And then half of 80 is 40. So we get this here. And let's just double check. Is this what they wanted? Yes, it is. So we got part A done. So we got it. 3k squared minus 62k plus 40 is equal to 0 as required. So that's done. And then let's look at part B. It says, given that the sequence converges, find the value of k given a reason for your answer. And the next part is we need to find the sum to infinity. So let's have a go at this. So part B, double I, or part BI, sorry. They've said that given the sequence converges, right, we need to find the value of k. Well, let's just write out what the equation is, because this is where it comes from, isn't it, right? 62k plus 40 is equal to 0. Now, remember, if a sequence converges, right, then that means the sum to infinity is a over 1 minus r, right? And this is for values of r which are in between 1 and minus 1, isn't it, right? So in our case, to figure out the value of k, well, let's just solve this equation here. Let me get my calculator and plug this in. So let me just clear this here. Let me just zoom out so you can see a bit better. So if I go to my equation solver, which is going to be here, polynomial, so quadratic, so it's going to be 3, and we've got minus 62, and we've got 40 here. This gives us k is equal to 20 for one answer. So I'm going to write k is equal to 20. And then the other answer is k is equal to 2/3. So we've got two values of k, right? So let's just go back to what we have. Now the question says that given that the sequence converges, we need to find the value of k. So k is either one of these two values here. Now remember, we determine whether a sequence converges, whether or not the common ratio is between 1 and -1. Now remember, we had an expression for the common ratio. It was these here. Now these are the same thing, so it doesn't matter which one you pick. So what you'd want to do essentially is plug in your values of k into your expressions for your common ratio, and then just check to see which one is in between uh plus or -1, isn't it? Right? So let's plug in k equals 20 and see what we get. So plug in that in. This will just give us, let me put this here. R will equal 12 minus 3 lots of 20 over 3 lots of 20 plus 4. Let's put this into the calculator and see what it gives us. So, oops, where's my calculator? So here we are. So let me go here. Let me go back to 1. And then it's going to be 12 minus 3 lots of 20 divided by 3 lots of 20 plus 4. This gives us negative 3/4. So it's going to be this one, isn't it? But what you want to do, imagine you're in an exam, just to be safe, I would plug in the other one too. So when we plug in k equals 20, sorry, we get r is equal to -3/4. So we're going to leave that here. Now let's plug in k equals 2/3 just to see what we get for it. 12 minus 3 lots of 2/3 over 3 lots of 2/3 plus 4. So plugging that in, I'm going to get my calculator again. And let me just zoom out again so you can see the working out. Now I'm going to just change this to 2/3, aren't I? So I'm going to change this to 2/3. And I'm going to change this one to 2/3 as well, aren't I? So this will give me 5/3, which is more than 1, isn't it? So this is outside the range of convergence. So we know it can't be this one, but we knew that anyway because of the way the question was set up. But it's always good to just double check. So let me just write this here. So we know that our r in this case is equal to 5/3, right? And this is just outside range of convergence. So I'm going to write range of convergence. So we know we're not using r equals 5/3. That means that our common ratio has to be -3/4. Now, oh yeah, so obviously that means that our value of k is going to be 20, isn't it? Right. So that's the actual answer to the question because it asks us to find the value of k. So the answer is k is equal to 20. But obviously that means that our common ratio is -3/4. But your answer is going to be k is equal to 20 for the first part of B. Now the second part of B says that we need to find the value of the sum to infinity. So let's do the second part of B, double I. We need to find the sum to infinity, which we know the formula is a over 1 take r. Now, what do we know? Remember, because we figured out that k has to equal 20, that meant that our common ratio was -3/4. So we know that our common ratio is -3/4. And then all we need to do is find out what a is, and that's the first term. Now, what was a? A was 3k plus 4, wasn't it? So I'm going to write a is equal to 3k plus 4, but we know that k is equal to 20. So if k is equal to 20, that means that our first term is going to be 3 lots of 20 plus 4, which is just going to be 60 plus 4, which is 64. So now we have all the tools we need to answer this question here. So we can say the sum to infinity then is going to equal a, which is 64, divided by 1 minus r, which is -3/4. And this is just 64 over 1 plus 3/4, isn't it? So I'm just going to put this into the calculator and see what it gives us. Let's put this into the calculator, see what it gives us here. Let's see. So let me just clear this, and then it's going to be 64 over 1 plus 3/4. So 64 over 1 plus 3/4. And then this gives me 256 over 7. So the answer for the sum to infinity is just 256 over 7. And we're done. Okay, so question 10 says a circle has equation x squared plus y squared plus 6kx minus 2ky plus 7 is equal to 0, where k is a constant. And we need to find, in terms of k, the coordinates of the center C and the radius. So this is just a standard circle question. The only difference is here is that we've got expressions in terms of k, right? But it's the same principle. So you're going to complete the square, aren't we? So let me just write this out. So we've got part A. I'm going to write out the equation of the circle again. So x squared plus y squared plus 6kx minus 2ky plus 7 is equal to 0. Now, what we want to do is complete the square. So I'm going to bring the x terms and the y terms together. So I've got x squared plus 6kx plus y squared minus 2ky plus 7 is equal to 0. Now I'm going to complete this square with these two terms, so we know what that will look like. We're going to have x plus, and then the coefficient of the x term is 6k. We half it, that will give us a 3k here. We're going to put a squared here, and we're going to take away the square of this term here, which is going to be 9k squared. So we'll take that away, and then plus, we're going to do the exact same thing with these two here. So it's going to be y minus, the coefficient of y is minus 2k. So if I half that will just give me a minus k. So I put minus k here, and then squared, and then we're going to take away the square of this. So it's going to be minus k squared. And then we've still got that plus 7, and it's equal to 0. So now let's just tidy everything up. So we're going to have x plus 3k all squared plus y minus k all squared. And then we've got this minus 9k squared and this minus k squared. That will give you minus 10k squared altogether, wouldn't it? So it'd be minus 10k squared plus the 7 is equal to 0. Now we're going to move these to the right hand side, because remember, k is a constant, so this is just a number. So we're going to move it to the right. So therefore we're going to have x plus 3k all squared plus y minus k all squared, and this will equal 10k squared minus 7, isn't it? Now the question asks us for the center and the radius. So the center, we can see quite clearly, is going to be, well, this is a plus 3k. We're going to do the opposite, so it's going to be minus 3k. And then this is just already in the form of x minus a, y minus b. So this is going to be k here. So let me just tie this up a bit more. So the center is going to be minus 3k and a k. So minus 3k and a k. This is our center of the circle. And then the radius is just going to be the square root, because remember, this is r squared at the moment, isn't it? So it's going to be the square root of 10k squared minus 7. So that's part A done. Now, part B says that the line with equation y equals 2x minus 1 intersects C at two distinct points. I need to find the range of possible values of k. So again, this is just standard quadratic inequalities, isn't it? So what I'm going to do, let me rewrite the equation of the circle again. I'm gonna write the expanded form out because I'm gonna have to do some algebra anyway. So it's gonna be easier if I use this form here. So I'm gonna write this out again. So it's gonna be x squared plus y squared, and then it was 6kx and minus 2ky, 6kx minus 2ky, and that's a plus 7, isn't it? Plus 7 is equal to 0. And now they told us that the line y equals 2x minus 1 intersects C at two distinct points. So if the line y equals 2x minus 1 intersects this circle here, intersects our circle, right? Then geometrically, there's going to be two solutions to, not even geometrically, algebraically there'll be two solutions, but geometrically there's going to be 2 points of intersection, isn't there? So when we attempt to solve this, we have to solve this simultaneously. We are going to get two solutions, and what will happen is that we're going to get some quadratic, and because there are 2 points of intersection, let me write this here, 2 points of intersection, we know that the discriminant will be greater than 0, sorry. So let's go ahead and do that. So we're going to plug in y equals 2x minus 1 into this here. So we're going to have x squared plus, and then I'm going to replace y with 2x minus 1. So 2x minus 1 all squared plus 6kx, and then minus 2k, and then y is 2x minus 1. I'm going to add 7, it's equal to 0. Tidying this all up. So I've got x squared if I expand this bracket, this is going to give me a 4x squared here, and then 2x and a minus 1, that'll give me minus 2k. Double that, that'll give me minus 4x, and that'll be a plus 1. And then plus 6kx, and then expanding that bracket, that'll give me a minus 4kx, plus 2k, plus 7. This is equal to 0. I'll tidy this up a tiny bit more. So let's look at the x squared terms. We have 5x squared all in all. And then the x terms, I've got a minus 4x and I've got nothing else in terms of x. I'm just going to leave it like that for now. So minus 4x here. And then I've got a 6kx and a minus 4kx. That'll give me a 2kx, wouldn't it? That'll give me a 2kx. And then what else do I have? And then here, I've got a 2k, and that's it, isn't it? And then I've got 1 plus 7. So the constant term is going to be the 2k, so plus 2k, and then 1 plus 7 is 8, so it'd be like that, and this is equal to 0. So now I've got this. Well, let's tidy up. Let's get this into a quadratic, right? So 5x squared, I'm going to take out the x term, right? If I take out the x term, like this, I will have, I'll write 2k minus 4, and then x here. I'm going to write it here. Now remember, let's just double check that. If I expand this, I'm going to x and a 2k, that will give me the plus 2kx here. And then minus 4x will give me minus 4x. I've just tidied it up so it's in a nice format. But if I expand this, you'll definitely get this. You can just double check if you want. Okay, so continuing. Then we've got plus 2k plus 8. And this is equal to 0. So now, remember, this is in a quadratic form. Now we know that when we solve this equation, we have to get two solutions because the question said that the line intersects at two distinct points. So that means that the discriminant of this has to be positive, it has to be greater than 0. So let me write out one more time here. So I've got 5x squared, and it was plus 2k. So was it 2, isn't it? Yeah, 2k minus 4. 2k minus 4 x plus 2k plus 8. And just put this here, is equal to 0, right? Now, what is our A, what is our B, and what is our C? Well, our A is clearly 5. Our B is the coefficient of x, which is 2k minus 4. And our C is the constant term, which is this whole thing here. So C is equal to 2k plus 8. Now, if there are 2 points of intersection, that means that the discriminant is greater than 0. I'm just going to write here 2 solutions, i.e. 2 points of intersection. I'm going to write 2 points of intersection, 2 POI, points of intersection. So now we're going to plug this in. So B squared is going to be 2k minus 4 all squared, minus 4 lots of A, which is 5, and then 2k plus 8, which is C. And this has to be greater than 0. So now tidying this up now, we're going to have 2k all squared. That will give us 4k squared. And then I've got 2k and times by minus 4, that'll give me minus 8k. Double that will give me minus 16k. And then this will give me minus 4 squared be plus 16. So this expands to give this. You can just double check if you want, if you just want to break it down. And just doing this here, this is 4 times 5 is a 20. I'm going to get 2k plus 8 is greater than 0. And to tidy this up a tiny bit more, so we're going to have 4k squared here, minus 16k plus 16, and then minus 40k minus 160, isn't it? This is greater than 0. Now tidying this up, well, we've got 4k squared, and then we've got minus 16 minus 40. That's going to give me minus 56 here. Okay, and then we've got 16 minus 160. That is going to give us minus 144, isn't it? And this is greater than 0. We need to solve this quadratic inequality. Now we can divide everything by 4, can't we? That will be k squared. Half of 56 is 28. Half of 28 is 14. This is 14k. And then half of 144 is 72. Half of 72 is 36. This is minus 36 here. Is greater than 0. Now we need to solve this here. Solve this quadratic inequality. Now, what we can do is figure out the root. So whenever you're solving a quadratic inequality, you want to sketch, don't you? Right? You want to see what's happening here. So I'm going to attempt to sketch this graph here. So what I need to do that though, I need the roots, isn't it? So let me just get my calculator, and then let's get the roots of this quadratic. Let me just zoom out a bit so you can see all of the working. So let me get my equation solver. So I'm going to go here. I'm going to go to polynomial 2. I'm going to get degree 2 here. Let's plug in the coefficients. We've got 1. We've got minus 14. And we've got minus 36, don't we? So one solution is k is equal to 7 plus root 85. That is one of the roots. And the other one is just going to be the negative of that, isn't it? Yeah, exactly. So 7 minus root 85. Now, I like to just make sure my sketch is completely accurate. So I'm just going to put in 7 minus root 85. It's definitely negative, isn't it? Because 7 is the same as square root of 49. So it's definitely negative. Putting this in here. SD is negative 2 point something. So it's going to be around here. So I'm going to write 7 minus root 85 here. And now remember, the y-intercept of this graph here, right, is minus 36. So I'm going to put this right here. And then the other one is going to be around here, isn't it? So it's going to be 7 plus root 85. So we've got everything we need to plot this graph here. So now we can just put a quadratic through it, isn't it? So it's going to look like this, like that. Now remember, we need to solve it when it's greater than 0. That's clearly when the graph is above the k-axis in this case, which is going to be here, and that consists of values or for these here. So more than 7 plus root 85 and less than 7 minus root 85. So your answers for the values of k, because answers for the range of k, isn't it? Find the range of possible values of k. So your answer is going to be this part here. So k is less than 7 minus root 85, or k is greater than 7 plus root 85. And you're done. Okay, question 11 says the value V pounds of a mobile phone T months after it was bought is modeled by V is equal to AB to the T, where A and B are constants. Figure 2 shows the linear relationship between log base 10 of V and T. The line passes through the point 0.03 and 10 2.79 is shown. Using these points, find the initial value of the phone. Okay, so with these types of modeling questions, the initial value is always going to be at the start, isn't it, where t is equal to 0. So all you're going to do for part A is make t equal to 0. And as you can see from the graph, this is also equal to where the log of v is equal to 3, isn't it, right? This is where t is equal to 0. So all we're going to do is just plug that in. So let me just do this here. So for part A initially, we know that t is equal to 0 and the log of v is equal to 3. So to get v now, we're just going to use our log rules to change this into exponential form. And that is the same as just putting both of these with a base of 10. So that will cancel that, and that will cancel. You're just left with v is equal to 10 to the power of 3, which is equal to 1,000. So initially the phone is £1,000. So I'm just going to write here £1,000. So fine, that's part A done. As well as that though, what I realized is the model in the question is actually v is equal to ab to the power of t, isn't it? So if I write this here, ab to the power of t, now initially t is still 0, right? So I'm gonna put t equals to 0. So I have ab to the power of 0, and this is just equal to v is equal to a times 1 because b to 0 is 1, and that just tells you that v is equal to a, and this is when t is equal to 0, isn't it? And we know that when t is equal to 0, v is 1,000. So that actually tells us that a is equal to 1,000 too, right? And this could be helpful later on down the line. But yeah, you could actually determine that a is equal to 1,000 from here. But let's just see what the next question says. So it says, for part B, find a complete equation for v in terms of t, given the exact value of a and given the value of b to 3 significant figures. Okay, so we know that a is 1,000, but I'll show you another way how to do it anyway. But yeah, let's see what we've got. So I've got part B here. Now let's look at all of the information that they've given us about this model. We've got 2 points, 0, 3, and 10, 2.79. So I'm going to write this here. 0, 3, and 10, and 2.79. And what else do we know? Obviously we have the model here as well, isn't it? So let's get this too. So we've got V is equal to a b to the power of t, isn't it? Now, what you want to do with a question like this, right, is remember the whole point of this topic here is you want to express some sort of exponential relationship in a linear form, and you do that by applying logs, isn't it? So what you're going to do is you're going to take the log of both sides to this equation, right? So that will give me log of base 10 of v is equal to log of base 10 of a b to the power of t. And then from our log laws, we know that we can split this into a sum. So log base 10 of a plus log base 10 of b to the power of t. Now remember, from our power rule in the log laws, this power of t can go to the front, isn't it? So I'm going to do that here. So let me rub that out. I'll put that t at the front here based on our log laws, right? And we still got this here. Now, this relationship is linear. So I'm going to express this in terms of the general formula of a line. So I'm just going to tally this up a bit, right? So I've got log of base 10 of v is equal to, and I'm going to move this term to the left. So I'm just going to swap it over. So it's going to be t, or no, I'm not going to put t. I'm going to put that at the end, and you'll see why. So I'm going to put this here, log of base 10 of b, and I'm going to put t in a different color just so it's clear to see that this is the variable. Remember, b is a constant, isn't it? And then plus log of base 10 of a. Now the reason for doing this is because, remember, because it's a line, it has the form y equals mx plus c, isn't it? So I'm going to write a capital Y here. This is equal to, this is our y, and then this is a constant here, log base 10 of b. That is a constant because b is a constant, so that's our gradient. And obviously t is our variable, so I'm going to call that x. And then plus the log base 10 of a, which is a constant too. So this is in the form y equals mx plus c. I remember what we're trying to calculate. We're trying to calculate b and a, right? Now, we can see quite clearly that the gradient is this here, isn't it, right? So how do we calculate the gradient? Well, we've actually got two coordinates that go through this line, isn't it? Because remember, it's a line at the end of the day, so it will still work. So what we're going to do is we're just going to do y2 minus y1 with those coordinates, aren't we? So let me just do this here. So we could say the gradient m, which we know is equal to log of base 10 of b, is going to equal 2.79 minus 3 divided by 10, isn't it? 10 minus 0 is just 10. And this here, that's just going to be negative 0.21 over 10. And this is equal to negative 0.021, isn't it? So now we can say that the log of base 10 of b is equal to negative 0.021. So now to calculate b, we're just going to put this into our calculator, isn't it? So or before that anyway, let's just get rid of the log base 10. So we're going to take 10, we're going to put them both with a base of 10 like this, and that will cancel with that. So that means we can say that b is equal to 10 to the negative 0.021. And then now I'm going to put it into the calculator. So let me just see what that is. Get my calculator here. This is going to give me 10 to the power of minus 0.021. And this is equal to 0.9527 blah blah blah, and they did want b to 3 significant figures, so that's going to be 0.953, isn't it? Yes, so we're going to put it there. So b is equal to 0.953. Perfect. So we've got our value for b. Now remember, we already know that a is equal to 1000, right? Because of this here. But the other way you can do it is, remember, if I look at this here, we can see that our constant term, right, has to be this. And then remember, if we look at the diagram, we can see that the constant term, right, the y-intercept, right, is 3, isn't it? So that just implies that this here, we've got this, don't we? We can just imply that we've got y is equal to mx plus 3. And that must mean that the log base 10 of a is equal to 3. And then getting a, this would just be a is equal to 10 to the power 3, which is equal to 1000. But we knew that anyway, right? This is just another way to do it, which is good. So we've pretty much done that now. So because we've got our values of a and b, we can now complete the model. Remember, it was v is equal to a b to the power of t. Because we know a and b, we can say v is equal to a, which is 1000, multiplied by b, which is a 0.953 to the power of t. And this is our answer for part B. And this is, how many marks is this? This is 3 marks. Brilliant. Okay. Now part C, what I'm going to do, let me just screen grab it. Let me just screenshot it and then do it here. It's only 2 marks, so it's not too bad. Let me just get it here and see what it says. Okay. So it says exactly 2 years after it was bought, right? The value of the phone was £320. Use the information to evaluate the reliability of the model. Okay, so remember what's going on here. We've got a mobile phone that is depreciating in value, right? And we're modeling it with this equation here, which we figured out the values of A and B. So we've got a complete model for it, right? So we've got V is equal to 1000 multiplied by 0.953 to the power of t, right? Now, this is going to determine the value of the mobile phone at any point in time. Now, exactly 2 years after, it was £320. This is a fact, right? Now, remember, your model is meant to, well, as much as possible, correlate to the fact here, right? It has to be reflective of it, isn't it? So that means when I plug in a value for t, which would represent 2 years, I should expect to get £320 or somewhere around that, right? Now, let's just remember what t was defined as, because you've got to be careful here. So remember, t is in months. So exactly 2 years after, that would be 24 months, isn't it? So we need to plug in t equals 24, not 2. So you've got to be careful here. So we're going to plug in t equals 24. And what we should expect to get is some value which is close to 320. So v is equal to 1000 multiplied by 0.953 to the power of 24. And let me get my calculator out and see what that gives us. So where's my calculator? Yeah, there it is. So it's going to be 1000 times by 0.953 to the power of 24. And this gives us 314.94, isn't it, right? So I'm just going to write V is equal to 314.94. Now, this is close to 320. It's not very, very close, but it's not a million miles away as well. So it's pretty much there and about. It's only £6 off, isn't it? If you think, or even £5 really. So I would definitely say that this is a suitable model, right? So I would just say, I would say 314. So I did the right one. 314.94 is close to £320. So therefore, the model is reliable or suitable. Model is, I'll use reliable. All right, slash suitable. And that's it. Question 11 done. Okay. So question 12 says y is equal to sine x, where x is measured in radians. Use differentiation from first principles to show that dy dx is equal to cos x. You may use without proof the formula for sine a plus or minus b. You may assume that as h tends to 0, sine h divided by h tends to 1, and cos h minus 1 divided by h tends to 0. Okay, so this is 5 marks. This is something that can come up. Obviously, it came up this year. 2023, but yeah, this is something you can even just memorize. So yeah, let's go ahead and do it. So we've got y is equal to sine x, right? And since we're differentiating from first principles, just to remind us of what that means that if y is equal to f of x, then your dy dx, which is equal to f dash of x, this will equal, from first principles, the lim as h tends to 0 of f of x plus h minus f of x all divided by h. So all you need to do here is just plug in your values of f of x and f of x plus h, and then use algebra to somehow get to cos x, and you can use these formulas and limits here. So let's go ahead and do that. So in our case here, we're going to say, okay, well, fine, we got f of x is equal to sine x then. Well, if that is the case, then f of x plus h will just equal sine of x plus h, wouldn't it? So now we can plug this in. So we're going to say that dy dx, or f dash of x, whatever you want to use, is going to equal the lim as h tends to 0 of f of x plus h, which is sine x plus h, minus sine x all over h. Okay, now remember the question said that we may assume the addition formula, isn't it? Right? So let's just remind yourself of where it is. You should memorize it. So we've got sine of a plus b. We know that this is equal to sine a cos b plus cos a sine b, isn't it? So if we've got x plus h instead, we're just going to swap those letters around, aren't we? So we're going to have sine x cos h and then cos x sine h, like this. So now we're going to plug this in here. We're going to plug this into this expression here. So it's going to be the lim as h tends to 0 then. All right, therefore, lim as h tends to 0 of, let me get a fraction larger so it's neat, like that. And then it's going to be this expression here, isn't it, in place of sine x plus h. So it's going to be sine x cos h plus cos x sine h minus the sine x. And this is all over h. Now remember, we need to somehow get this to cos x, and we just need to use algebra to do that. Remember, we've also got these limits that we can assume too. So this is going to come in handy. So just having a look at this though, let me just zoom in a bit. What I would do is say, okay, fine. Well, if I look at these terms here, I can see that I've got a common factor of sine x here, and then this one. So if I take out a factor of sine x just for those two, right? Put this here. Then that will give me I'll put a sine x on the outside, this, and then in a bracket, it's just going to be, well, it's going to be cos h for this term here. And then if I take out a sine x, I'll be left with minus 1. So we get this here. Let me just make this a bit lower. Allow me to? No, it won't. Oh, what was it? Yeah, just want to move this down a bit. Yeah, brilliant. Okay, so that's fine. And then continuing, we've got this here that we didn't touch. So plus cos x sine h here. And this is all over h still. And don't forget your lim as h goes to 0 as I just did. So let me put lim as h goes to 0. So lim as h tends to 0. So now what can we do here? Now remember, let's get those limits that they said that we can assume, because you want to use algebra to somehow get those expressions into your formula here, into your expression here, so it's easy to use. So I'm just going to put this, I'm going to paste this here, and then I'm going to just make it a bit small so we can just call it here. And what I'll do, let me get this again here. So let me copy this, copy that there, and then I'll paste it here so we can just continue with what we're doing. All right, so the aim is to get these, oops, where's it gone? So it's looking for, so I've gone all the way to the top again. Let me just go and get this down. Done that. Okay, yeah, so we are, where are we? Yeah, we're here. So the aim is to get these limits, right, in your expression here somehow. So that's not too bad, because as we can see, what I could do is I'm going to split the fraction, isn't it? So I get this here. So I'm going to have sine x and then cos h minus 1 all over h, right? And if I split it, that would mean that I would have the lim as h tends to 0 for this term as well, isn't it? Because I'm splitting it. So it's going to be cos x sine h, right? Divided by h, right? So I've just split the fraction into two terms, right? So we can do that. That's not a problem. Now remember, we are looking at the lim as h tends to 0, right? Now h is the variable in question here. We've got an x, right? And we've also got an x here. So this is not going to affect the limit. So what you actually can do is just take out the x term. So the expressions with x in them, you can take them out. So you can write it as sine x, right? And the lim as h tends to 0 of your expression, which is cos h minus 1 all divided by h, plus, and then I'm going to take out the cos x, so I get cos x here, and then the lim as h tends to 0 of sine h divided by h. Now let's look again at what these limits were. As h tends to 0, sine h of h tends to 1, and as cos h and as h tends to 0, cos h minus 1 of h tends to 0, isn't it? So we could say, well, fine, this right here, I'll write this, let me do it in a different color. This in green, this whole thing in green, right? We know tends to 0 right here, isn't it? We've got this here. So I can just replace that with a 0, can't I? So therefore, this will just give me the sine x times by 0 plus, and then this one, the lim as h tends to 0 of sine h over h, we know that that tends to 1 right here, right here. So we could say then, this here in yellow, I can just replace with, or sorry, not this whole thing too, because this is part of it. This here, I can replace with a 1. So we get cos x multiplied by 1. And then that there, well, that's just 0. This is plus cos x. And this is equal to cos x. So we've got cos x now. To get the final marks, just need to conclude. Therefore, remember what we showed here is that from differentiation from first principles, we started with this expression here, which was dy dx, and we got to all the way down to cos x. So therefore, dy dx is equal to cos x as required. And we're done. That'll give you 5 marks. So question 13 says, on a roller coaster ride, passengers travel in carriages around the track. On the ride, carriages complete multiple circuits of the track such that the maximum vertical height of a carriage above the ground is 60 meters. A carriage starts a circuit at a vertical height of 2 meters above the ground. The ground is horizontal. The vertical height, h meters, of a carriage above the ground, t seconds after the carriage starts the first circuit is modeled by the equation h is equal to a minus b t minus 20 all squared, where a and b are positive constants. And for part A, we need to find a complete equation for this model. Okay, so what I'm going to do is I'm going to screenshot these 3 bullet points here because this is where all the information is, isn't it? So I'm just going to screenshot this, paste this here, and then move this into the text, into the lines. And then our model, let me just remind myself, was h equals a minus b t minus 20 squared. So h is equal to a minus b, and then t minus 20 all squared. Now, when I look at this, well, what type of model is this? This is a quadratic, right? And it's a completed square form. So what I would do when I look at this is I would remind myself of the general expression for a turning point, especially because of the fact that they've told us about maximum height. So if I just write this, y is equal to, and I say a, and then capital A, x plus p all squared, and then plus q, then the general turning point, remember, is always going to be, the x coordinate is going to be the flip of this number here. So this is a plus p, it becomes a negative p. And then the number in the end is just a q, so you just keep that the same. This is the general turning point of any completed square form. Now, if I look at this, if I was to swap these two over, right, then that would mean I would have h is equal to, and it'll be negative b, and it'll be t minus 20 all squared, and then plus a. And then you can see it takes the exact same form, doesn't it? So the turning point in this case would be, well, the x coordinate, or the t1 in this case, this is a negative 20. I'm going to flip it over to be positive 20. And the number at the end is just a. So we've got a turning point at 28 for our model. Now, because I have a negative sign here, I know that my model is going to look like this. Right? Now, in the context of what we found, the turning point was going to be a t coordinate of 20 here on the t-axis, and the maximum height, right, is going to be at a, like this, isn't it? Yeah. So if I look at the first bullet point, it tells us that the maximum vertical height of the carriage above the ground is 60. So that must mean that for sure that a is equal to 60. 100%. So that means we could say that our model then, just to finish off, will just become, or so far I should say, well, we know that a is 60, so it's just going to be, a is 60, so it'll be 60 minus, and then b, and then t minus 20 squared so far. So remember, we're trying to find a complete model, so we just need a and b. We figured out what a is, now we need to find b. So what I'm going to do is I'm just going to write that model here again. So far we know that a is 60, so it's h is equal to 60 minus b, and then t minus 20 all squared, right? And now let's look at the second bullet point. The second bullet point tells us that a carriage starts a circuit at a vertical height of 2 meters above the ground. Now, when I look at that, the word that sticks out to me is that starts, right? Starts at the beginning, initially. These are all synonyms for just t is equal to 0, isn't it? So in other words, when t equals 0, h is equal to 2. Yeah. So what we can do is just plug in these into our formula to figure out what B is. Yeah. So let's do that. So we know that when T is equal to 0, H is equal to 2. So if I was to plug that in, then that will give me 2 is equal to 60 minus B, and then T is 0, isn't it? So it just becomes negative 20 all squared. And then now tidying this up, well, I'm going to have 2 is equal to 60, and then minus, and then negative 20 is, negative 20 squared is 400, isn't it? So this is just going to be minus 400, and I'm going to have B here. And tidying this up, I'm going to move the minus 400B to the left, and then move the 2 over to the right, that'll be 58. That tells us that B is equal to 58 over 400. And I can just simplify this by dividing by 2 top and bottom to give me 29 over 200. So now I know what B is. We've completed our model. So therefore, we can say that the complete model is going to be H is equal to 60 minus 29 over 200. And then T minus 20 squared. So that is done. Part A is done. So let's go to part B. 1 mark, it says use the model to determine the height of the carriage above the ground when T is equal to 40. That's not too bad. We're just going to plug in T equals 40, isn't it, into our model and see what it gives us. So part B, we're plugging in T is equal to 40 to figure out what H is. So when we do that, that will give us H is equal to 60 minus 29 over 200. And then we're going to have T is equal to 40, isn't it? So I'm going to have 40 take 20 all squared, isn't it? So now, doing this, I can just put this in my calculator. Let me do this here. I've got already here for us 60 minus 29 over 200, and then 40 take 20. Yeah, this is 2. So therefore, H is equal to 2. So that is done. Now, when you're doing these types of modeling questions, it's always good to visualize what you've actually done here. So we've got a model. I'm just going to get an axis, right? This. We've got a model, right, that we know started at a height of 2, right? Started at a height of 2. So I'm going to say, let's say 2 is here. And then it has a maximum height of 60, right? Which we know occurs 20 seconds after it starts moving, right? That's at 60. And then it's going to drop down. And then we know that 40 seconds from the beginning, it's back at a height of 2. So this is going to be 40 seconds. And then obviously it may just continue until it hits the ground. So this is our model for this one anyway. It's just always good to have. Now, let's go to part C. Part C says, in an alternative model, the vertical height h meters of a carriage above the ground, t seconds after the carriage starts the first circuit is given by h is equal to 29 cosine 9t plus alpha plus beta, where alpha is between 0 and 360 and alpha and beta are constants. Find a complete equation for the alternative model for 2 marks. Okay, so we just need alpha and beta, right? Now, what I'm going to do, let me just screenshot this piece of information here. And how much room do I have? Yeah, I'll do it. I'll start it here. Why not? So it's here, and then I'll just make it small so we can fit into the text. So this is the information that we have here. Now remember, although this is an alternative model, the initial conditions are still applicable here, isn't it? Because we're just modeling it in a different sense. We're modeling it in a trigonometric sense now, as opposed to a quadratic, right? So I'm gonna get those I'm gonna get those bullet points too, because they're still gonna be helpful, right? Now, we know that the maximum height of the carriage is 60, and we've got this model here, which is a trigonometric one, right? And we know that this is of the form r cosine plus alpha, isn't it? Cosine theta, sorry, plus alpha, right? And we know that just from the graph in general, right? If I have a maximum, I'll just get this here. If I have the graph of cosine x, right, which we know looks like this, goes between 1 and -1, right? Now, if I apply a number here, say r, right, then that will stretch the graph vertically, right? It will be between r and -r. Now, in our case, that number on the end is 29, isn't it? So let's forget about the beta for now, right? We're gonna look at that in a second. So just from that, we could see that for sure that would mean that this graph here would oscillate between 29 and -29, isn't it? Yeah. So it will look like this, basically. Yeah. Now, we know that the maximum vertical height above the ground is 60 meters, right? At the moment, without the beta, right, our maximum is 29. So how can we get this to be 60? Well, you just have to be very good at your graph transformations, right? What will happen is that the graph will have to shift vertically upwards, wouldn't it, right? So if I have the graph like this, then it would have to shift vertically upwards, right, until I get to 60, wouldn't it? And that would mean that I would have to add on how many? Well, what is 60 take away 29 is 31, isn't it? So therefore, I would have to add on 31. So basically what we're saying is that to go from 29 to 60, I have to add on 31. And that would mean that this minus 29, well, what's minus 29 add 31? It would be 2, wouldn't it? So therefore, it would be at 2. So I'll just draw one more graph like this. So the graph would look like this. So it'll be 60 here, it will be 2 here, and the graph will just look like this, wouldn't it? Like that, it will just have waves like this. So that means for sure that the number that we add on is going to be beta, which is definitely 31, right? Beta is definitely 31 for sure. So we could say that, I'll do this on the next page. We have h is equal to 29 cosine of 9t plus alpha plus beta, which is 31 now. Now, the second bullet point tells us that a carriage starts a circuit at a vertical height of 2 meters above the ground. So again, we can just plug in t equals 0 and h equals 2 to figure out what alpha is, right? So let me just copy that here, put this here. Let me just screenshot this and put this smaller so it can fit on the screen. So yeah, we're just going to plug in t equals 0, and h is equal to 2. And we know that alpha was between 0 and 360, so it's just going to give us 2 is equal to 29 cosine of 9t plus, sorry, not 9t because t is 0, isn't it? So that will just be alpha, isn't it, to be fair? That'll be alpha, and then plus 31. And then now, well, if I move the 31 over to the left, that will give me minus 29 is equal to 29 cosine of alpha, meaning that minus 1 is equal to cosine of alpha. And we know that that occurs when alpha is equal to 180 degrees, isn't it? So therefore, alpha is equal to 180. And now we consider that, therefore, our complete model for this question here, I'll do it here, would be h is equal to 29 cosine of 9t plus 180 plus 31. And that is our answer for part C. I think there was one more, wasn't there? Right, so yeah, part D says, given that the carriage moves continuously for 2 minutes, give a reason why the alternative model would be appropriate, right? Okay, so let's have a look at this. There's only one mark, so there's not much that's needed, right? You can just plug in t is equal to 120, right? Because remember, t was in seconds, this is 2 minutes. Plug in t equals 120 in both and see what you get, right? Or you can actually just visualize it as well. So remember, this was our model for the quadratic, right? Now, I'm going to put them side by side like this here. It's our model for the quadratic, right? We know that it starts at a height of 2, then 40 seconds later, it gets back to 2. Well, anything after 40 seconds is going to go crashing down and hit the ground eventually. So that is definitely not a good model to use because it only lasts 40 seconds. Now, our model, the trig one, I'm going to call this quad, and then our model, the trig one, well, if I was to just do a little sketch, right? It's going to be like this here. I'm going to move this here. Now, we know that from our model, it oscillates between a height of 2, right? And then the maximum height is at 60. We knew that from part B, right? And what else do we know? Based on this model here, the 9t just would compress the waves, isn't it? The graph would have 9 times as many waves, isn't it? So what will happen is that the graph will actually just look like this. We'll start at 2, then we'll go up to 60, and it'll just keep going up and down like this, right? So there's a couple of things here. Well, the graph doesn't actually fall anywhere below 2 meters, so it has no chance of hitting the ground. That's a good thing, as well as that there are more waves as well, right? So one thing you could say is that there are more cycles. You get more cycles with with the trigonometric model, the alternative model. Another thing is that it doesn't touch the ground. Doesn't touch the ground after 2 minutes. Doesn't touch the ground. It never touches the ground, actually, I should say. So yeah, that would be your answer. But yeah, this is just a couple of ways you could have done it. And yeah, this question 13 finished. Okay, so question 14 says, prove using algebra that n plus 1 all cubed minus n cubed is odd for all n in n where n is a natural set of numbers. So this one isn't too bad. All you've got to do is just remember, you've got two types of numbers for natural numbers, right? You've either got odd integers or even integers. You're going to try both scenarios, and then just hopefully when you put it into this expression here, algebraically you should get an odd result. So we'll start with the first one. So let's just say I have an even number, which we know we can express as 2k. We're going to plug 2k into this, and then hopefully when we expand and simplify, we'll get an odd result out algebraically. So let's go ahead and do that. So doing this, I'm going to have 2k plus 1 all cubed minus 2k all cubed. And then expanding this one, I'm going to have 2k plus 1 and then another 2k plus 1 and then another 2k plus 1. And then minus 2k all cubed is just 8k cubed, isn't it? So that one is just 8k cubed. And then now we just have to be very careful with this expansion. So let's do these two first. So this one in the bracket here, this will give me a 4k squared plus 2k plus another 2k here, and then plus 1. Then I've got 2k plus 1 here, and then minus 8k cubed. And then simplifying that, sorry, I'm going to get 4k squared plus 4k plus 1. Then I've got 2k plus 1 here. Okay, and then minus 8k cubed. All right, now expanding this one will give me 4k squared and 2k. That will give me 8k cubed. And then I've got 4k squared times 1, which is just 4k squared. And then these two here will give me 8k squared. And then this one will give me a 4k. And then when I times this bracket by 1, right, I'm just going to get the exact same thing. So I'm just going to get 2k plus 1. And then I'm minusing the 8k cubed. So now we are here. Now if I look at this, I've got an 8k cubed here, and I've got a minus 8k cubed there. Those two will cancel, isn't it? So I won't have any cubic terms. And then these two, 4k squared plus 8k squared, that's going to be 12k squared, isn't it? And then I've got a 4k and a 2k, which will give me a 6k. I've got the plus 1. So this is what we get when we expand and simplify. Now, remember, we need to show that this is an odd result, right? Now, what I can do is if I look at the first two terms, I can see a common factor of 6k. Then I'll have 2k here and I have plus 1. I've got plus 1. So we just need to analyze this and see if it's an odd expression. Now, the first term on the outside is a 6k. Now, this is just a multiple of 2k, isn't it, right? Which we know is even. Let me just write this here. This is even, isn't it? Yeah? Now, if 6k is a multiple of an even number, that means that this is an even number too, for sure. So this is even. Whoops. Sorry about that. Just tidy that up. So we're going to have, this is even. And then this one here, well, we've got 2k, which is even, and I'm adding 1. 1 more than an even number is an odd number. So therefore, I've got an even and an odd plus 1. And we know that an even times an odd number is always an even number. So this is just an even plus 1. And again, 1 more than an even number is an odd. So therefore, we've shown that we can say, therefore, when n is even, or in other words, 2k, yeah, we get that n plus 1 all cubed minus n cubed is odd. So we've proved that part. Now we've just got to do the second part, which is using an odd number now. So I'm going to write 2, and I'm going to write odd, right? And that would mean, whoops, sorry. That would mean that n is equal to 2k plus 1. So again, we are going to plug 2k plus 1 into n plus 1 all cubed minus n cubed, and then hopefully when we plug it in and expand and simplify, we get a number out, or an odd expression. So let's go ahead and do that. So we're going to have a 2k plus 1, that's n, and then I have to add 1, don't I? So I have to add 1 here, then cubed, and then minus 2k plus 1 all cubed. like this, and then tidying this up a little bit more, this will give us 2k plus 2 all cubed minus 2k plus 1 all cubed. Now looking at this one here, looking at the first one, I'm just going to go over here quickly. So I've got 2k plus 2 all cubed, right? Now I can take out a factor of 2, can't I? And say this is just 2 lots of k plus 1 all cubed, like this. Now remember, there's an index law that states that if I have a times b all to the power of n, then this is just going to be a to the power of n, b to the power of n. You can just separate the factors and put it to the same power. So if I apply that same logic, right, then I can write this as 2 to the power of 3 and then k plus 1 to the power of 3, can't I? And then obviously 2 cubed is 8. So we've got 8 lots of k plus 1 all cubed that we need to expand and simplify. So this makes it a little bit easier because we don't have to keep multiplying by that 2 because it's just going to give us an 8. So now I'm just going to write this here that we know that 2k plus 2 all cubed is just the same as 8 lots of k plus 1 all cubed. And then we're minusing 2k plus 1 all cubed. Okay, now let's have a look at what we can do. So for this one, I've got 8 lots of k plus 1 all cubed. So I'm just going to write that 3 times. K plus 1, and then a k plus 1, and a k plus 1. And then minus, and then 2k plus 1 all cubed is actually something we did already, isn't it? It was, we did this right here. This is the expansion where we do 2k plus 1 all cubed. So instead of writing that out again and doing all of this, I'm just going to copy that because I've already done it. So the examiner can see that, so that's fine. I'm going to copy this here. And then I'm going to paste this here and then move this right here. So that is fine. And obviously because we're taking away, don't ever forget to put your bracket around it. So let me just change the color. So don't forget to put your bracket around it like this. Now, let's have a go and see what we get then. So this one, I've got 8 and then k plus 1 times k plus 1 is a result we should know. This is just k squared plus 2k plus 1. And then I've got the k plus 1 here. And then tidying this up a little bit more, this will give us 8. And then I'm going to do these now. So k squared times k is going to be k cubed. So I'm going to write k cubed like this. And then it's going to be plus k squared. And then I've got 2k times k, which is 2k squared. And I've got 2k times 1, which is just a 2k. 2k. And then the last one, I've got 1 times k, which is just a k. And then I've got 1 times 1, which is just 1. So I've got this here, and then I'm going to take away, and then inside this one, if I simplify this a tiny bit more, I'm going to have 8k cubed, and then I have 4k squared plus 8k squared, which is 12k squared. And then 4k and a 2k is a 6k, and then plus 1. So I've got this here. I think I could have actually simplified it a bit more, couldn't I? But anyways, doesn't matter. All the same. So we've got this here. Let's tidy this up on this last line and do it on the line underneath. So I'm going to have 8 lots of, and then it's going to be k cubed plus 3k squared plus 3k plus 1. And then minus, and then expanding that minus, remember this is just a minus 1. So it's going to be minus 8k cubed minus 12k squared minus 6k minus 1. That's what we need to sort out. So I'm just going to copy this and then put it on the next page. So copy this here, put this on the next page. I always need to paste it on the outside because we'll just mess it up. Put this in now like this, and then we're nearly done. Oops. Where's it gone? So I need to go down here. I guess I skipped a bit, so I need to go all the way down. Okay, so I've got this here. Okay, so continuing. So we have now we're going to expand the 8, so it's going to give us 8k cubed plus 24k squared plus 24k. Oops, plus 24k. Sorry. Plus 8, and then minus the 8k cubed, minus the 12k squared, and then minus the 6k, and then minus the 1. And then tidying everything up here, well, I've got an 8k cubed here, I've got a minus 8k cubed here, those will cancel out. So goodbye and goodbye. And then what else do I have? I've got a 24k squared, which is right here. Then I've got a minus 12k squared, which is right here. That's going to give me 12 lots of k squared altogether. So 12k squared here. And then what else do I have? I've got 24 minus 6k, which is 18k. Sorry, not 8, 18k. And I've got 8 minus 1, which is 7. So I get this here. And now if I analyze this, again, I can factor out something from these two. I could take out a 6k, and that will give me 2k plus 3, and then add 7. So now we've got to analyze this. And again, 6k is a multiple of 2k, which is an even number. So this must be even. And then inside the bracket, well, 2k is an even number, right? And then I'm adding an odd number, 3. An even plus an odd is always an odd, isn't it? Yeah? And then plus 7. So now we've got an even times an odd again, which we know that's always an even. And then an even plus 7 is just an even number plus an odd number, right? This is always an odd number. So what have we done? We've proved that when n is equal to an odd number here, right, we get all the way down to an odd result. So we can just say, therefore, when n is odd, right, or in other words, 2k plus 1, yeah, we get that the expression n plus 1 all cubed minus n cubed is odd, right? So coupled with these two, so the first one, remember, was that we proved that when n was even, we got an odd result out. And then when n was odd, we also got odd result out. So therefore, we could say when n is even and when n is odd, right? Both of them give us n plus 1 cubed minus n cubed is odd. Sorry, I forgot is odd here. Is odd. Hence proven. So we've proven the statement because we showed that when n was even, we got an odd result out, and when n was odd, we also got an odd result out. So coupled with those together, we can prove that the statement is true. So we're done. That is it for that one. Okay, so question 15 says a curve has equation y equals f of x, where f of x is equal to 7x e to the x divided by the square root of e to the 3x take 2, where x is greater than the ln of a cube root of 2. Part A says show that f dash of x is equal to 7e to the x multiplied by e to the 3x multiplied by 2 take x plus ax plus b, all divided by 2e to the 3x take 2, all to the power of 3 over 2, where a and b are constants to be found for 5 marks. Okay, so this one definitely looks very, very tricky for sure. But what you can do is say, okay, well, fine. We've got f of x and they're asking us to show what f dash of x is. So that just means we need to differentiate, right? And obviously we've got a fraction in front of us. So we need to use the quotient rule for differentiation. So what I'm going to do is I'm just going to screenshot this f dash of x here, just so I have it. Whenever you're doing a show that question, whether it's trig, differentiation, whatever it is, always have it in hand so you can actually just compare what you've got. So we've got this here, and let me put this here, and then I remember what the derivative is. I mean, what the function is. So f of x was equal to 7x e to the x, and then this was all over the square root of e to the 3x take 2. Yeah. Now we need to differentiate this using the quotient rule, and we can see that we've got a u here and we've got v. So let's just remind ourselves of the quotient rule. If f of x is equal to u over v, then f dash of x is equal to vu dash take uv dash over v squared, isn't it? This is our quotient rule here. So what we need to do is just figure out our u, figure out our v, find our dashes as well, and then plug them all into this formula. So we can see that u is equal to 7x e to the x. And we can see that v is equal to the square root of e to the 3x take 2. And another thing you can do as well is whenever you're having to differentiate, right, is whenever you see square roots, you can actually just rewrite them as powers, isn't it? And that will be very handy. So let me just rub this out here. This square root, right, we know anything that is square rooted is the same as writing it to the power of 1/2. So I'm going to write that I'm going to write that there, and then this means that I'm going to write this as a half too. And this will be very handy when we differentiate this. Anyways, so let's start with u, and that is 7x e to the x. When I look at this though, I've got a 7x right here, and I've got an e to the x right here. Now these are two completely different functions, and I need to differentiate the product of these. So we actually need to use the product rule here, don't we? So with that one, this will be our u and this will be our v. And then remember the product rule says if f of x is equal to u v, so multiply together, f dash of x is just equal to u v dash plus v u dash, isn't it? Right? And yeah, so what we're going to do now is just plug these in. So we're going to have a u is equal to 7x, and we're going to have v is equal to e to the x. Now that means that u dash is just going to equal 7 when I differentiate that, and then v dash will just equal e to the x. Now remember, the product rule states that we have to do u v dash and then plus vu dash. So we're going to times these together. So therefore, you can say that this will just become 7x e to the x for uv dash, 7x e to the x, and then plus, and then we times these two together. That's just 7 e to the x, isn't it? Now, this is done here. This is our u dash, isn't it? This is our u dash for our original quotient rule. So remember, this here is a product rule within a quotient rule. So what I'll do actually, you know what, I'm going to rub this out for now so it's not confusing, right? Because we have a u dash right here. So I'm just going to leave this here for now, right? This is it done. Now let's go to v. If I have a look at v here, I can see that we've got e to the 3x take 2 all to the half. Now, if I wanted to differentiate this, I would have to use the chain rule, wouldn't I? So I've got a function here of another function. So this half can drop to the front. So it'd be 1/2 e to the 3x, half goes on the outside, and then you're going to take 1 away from the power, so it's going to be minus a half, right? And then remember, you have to multiply by the derivative of the inside bracket, isn't it? The inside function. And that will be e to the 3x differentiates to, well, remember, you differentiate the power of 3x, that will give you 3, and you multiply by e to the 3x. And then obviously minus 2 differentiates to 0. So this is what you're left with. And then I'm just going to tidy this up a bit more because I've got a half here. I've got a 1/2 and I've got a 3. That could make 3 over 2. 3 over 2. And then that e to the 3x I can put next to it like this. Then I have this here. So I've got e to the 3x take 2 all to the minus a half. So now we've got v dash. And we also had u dash here. So what we can do now is remember, is we need to differentiate this function here and show that we get this. Remember, we identified that we needed to use the quotient rule. So what we're going to do now is we're going to plug in our u's and v's and v dashes and u dashes into this formula here. So what I'm going to do, let me just copy this. I'm going to copy this right here. And then I'm just going to bring it down here, like this. And then I'm going to bring my u's and u dashes and my v's and v dashes. So my u was right here. Let me just copy this. Copy, paste here. And then my u dash was 7x e to the x, isn't it? Plus 7 e to the x. So I'm going to say u dash, again, was a 7x e to the x plus 7 e to the x. And then our v was equal to, what was our v again? Our v was this one here, e to the 3x minus 2 all to the half. E to the 3x minus 2 all to the half. And then our v dash was equal to 3 over 2 e to the 3x, 3 over 2 e to the 3x, and then it was, what was the bracket here? E to the 3x minus 2. E to the 3x minus 2, and then this was all to the power of negative 1/2. So we've got this here. Okay, so now we're in the position because we've got our u's, u dashes, our v's and v dashes. We can use the quotient rule. So all we're going to do here is plug in everything into the formula here. So how much room do I have on this page? I have a bit of room, so I'll just do it. I'll start it and then go to the next page. So that means that f dash of x then is going to equal, let me just get a nice fraction bar. Nice fraction bar like this. And then let's see what we've got. We're going to do VU dash, so these two, VU dash, so it's going to be e to the 3x, take 2, all to the half, and then we're going to multiply by this bracket here, which is 7x e to the x plus 7 e to the x. And then we're going to take away uv dash, which are these two right here, isn't it? So that is just going to be 7x e to the x. And then we're going to multiply this by 3 over 2 e to the 3x. And then e to the 3x. Take 2, all to the minus a half. So I actually need more room for my fraction bar. So let me just extend this here. It lets me. Okay, perfect. So that means we've got the numerator done. And then the denominator is v squared, isn't it? Now remember, this is v right here. If I square this, right, then this will just become e to the 3x, take 2 all to the half, and then all squared, isn't it, right? And then obviously a power of a power, we just times these together. A half times 2 is going to be 1, isn't it? So therefore, it will just be e to the 3x, take 2 all to the power of 1. Or I can just write this as e to the 3x, take 2. So this is what we've got here for our f dash of x, right? Now remember, we have a show that question. Always have in mind what you need to show. So let me just get this here again. So we need to show this expression here. And we've got this so far. So we just need to use algebra to manipulate this and then hopefully get that. So what I'm going to do, I'm going to copy this here and then put this on the next page as well. Put this here. So just because I've got a bit of room. All right. Now let's just see. I'm going to copy this too because I'm going to need it. Copy. I'm going to need this too. So let's see what we've got here. Now, remember, we need to get this on the right-hand side. So what I would do is whenever I see something like this here, is what I'd want to do is analyze the factors and everything. So what I can see here is that I've actually got this here, and this is a minus a half, isn't it? Right? Now, that minus a half I can actually write as a fraction. That there is actually just the same as 1 over e to the 3x take 2 all to the power of 1/2. Right? So I can actually write this as a fraction, can't I? So that would be on the denominator. So what I'm going to do, so I'm going to highlight everything that'll be on the denominator. This will be on the denominator, like this here. And then also, I also have a 2 right here, don't I? This is a division of 2. So those in blue will be on the denominator and everything in green, right? Because these are all multiplying, this 3 here and then this e to the 3x. This will all be on the numerator, wouldn't it? So the greens will be on the top, the blues will be on the bottom. So what will happen here is that, you know what I'm going to do? Just so it's clear, I'm just going to copy this here. I'm going to copy this fraction bar and then paste it here. Whoops, that was not what I meant to do. Let me just copy it. Okay, paste, and then let me bring this here. So what will happen is that the actual expression itself will just look like this, isn't it? So I'll just do this here. So I'm going to have a minus, and then on the numerator, I'll have this in green. Now, if I simplify this in green, I've got a 7 and a 3. That will make 21. And then I've got an x. I've got an x, right? And then I've got e to the x, and I've got e to the 3x. We need to add the powers to get that. X plus 3x is 4x. So I have that on the top. And then on the bottom, I'm going to have this here, isn't it? I'm going to have the things in blue. So I'll have a 2 here. That 2 is there. And then I'll have I have a bracket here, and I have e to the 3x, take 2. And then this is all to the power of 1/2, isn't it? So I get this here. So this here is the exact same as that. Then I've also got this here. So I've got e to the 3x, take 2 to the half, and then I've got 7x e to the x plus 7 e to the x, like this. This is what I'm at so far, and then I've obviously got this at the bottom, don't I? E to the 3x, take 2. Now, whenever I see anything like this, when I'm dealing with A-level maths, right, I can see that I've got one term, which is not a fraction, and then I have another fraction. I have a fraction here. What I'd always do is just combine these two to get one term. So combine them, make sure you have a common denominator. So let's go ahead and do that on the top here. So I'm going to get another fraction bar like this here. And then if you think of it right, I'm going to write this out again. So I'm going to have a minus here. I'm going to have 21 x e to the 4x. and then this is all over 2, and then e to the 3x take 2 to the half. Right, and then now this one, because we want a common denominator, well, the common denominator is going to be just this denominator here, 2 e to the 3x take 2 all to the half. Now, what I like to do just to really make it stick with me is if I just, I'm going to just make it a bit longer. These two terms are already there, yeah? So I'm going to write these here. So e to the 3x take 2 to the half, and then I have the 7x e to the x plus 7 e to the x here, like this. And then remember, because I want to make the fractions equivalent, I've multiplied by 2 e to the 3x take 2 to the half on the denominator. I have to do the exact same thing on the numerator, so it's equivalent. So I get this here, minus 2, and then it's all to the half. And now if you just check here, if I just highlight this here, and I highlight this here, right? These would cancel out and I'll be left with exactly what I've got here on the numerator. So these are equivalent. This is perfectly fine. You know, just to convince yourself. And then obviously we've still got this here. E to the 3x take 2. Now, what we can do now is there's a couple of things we can do to simplify. Now, what I can see here is that I've got the same bracket e to the 3x take 2, e to the 3x take 2, and then I've got a half here, and I'm multiplying them together. So I'm just squaring something with a half. So that means that they will cancel out, isn't it? The half and the 2 when I square them. So what will happen is that in this case, this bracket right here, these three terms multiplying together right here, will just be a 2, and then it will be e to the 3x take 2, that. And then this will give us 7x e to the x here, plus 7 e to the x, like this. And then we're going to write everything else. So this is going to be all over 2 e to the 3x take 2 to the half, and then minus 21x e to the 4x over 2, and then e to the 3x take 2 to the half. And then this is all over e to the 3x take 2. So, okay, now what else do I need to do? Because they now have the same denominator, I can combine them, can't I? So what I'm going to get then is if I just do one more line like this. So I'm going to have the fraction line of this here. And then this is e to the 3x take 2. And then on the numerator, sorry, I have another fraction, don't I? Yeah? I think I might need to lower this a little bit. Let me just lower this here. Lower this tiny bit so there's room. So and then move this up a little bit. Okay. So on the numerator, it's going to be 2 and then e to the 3x take 2, and then 7x e to the x plus 7 e to the x minus 21x e to the 4x. And then this is all over this denominator right here. This is the denominator right here. So it's just going to be it's going to be 2 and then e to the 3x minus 2 all to the half. Okay, so we're here now. Now, when I look at this, I've got a fraction on the numerator, and then I've got it all divided by something on the denominator, obviously. So this looks a bit tricky. Now, there's something you can do to simplify this a lot. So what I'm going to just show you is, for example, let's say I have x divided by y. This is all over z, right? Now, if you think about this, this x over y is a number, right? It's on the numerator. So I can actually just bring this to the front and give you x over y, and then this will be multiplied by 1 over z, right? These are actually the same thing. And what happens is that x will be on the top, and then yz will just be on the bottom. So the whole point is that this denominator here and this denominator right here can just go under the same fraction bar, right? So if I apply that logic here, it means that I can write this one here and this one here all under the same bar. So I'm going to go ahead and do that. So just going to get a fraction bar like this. And then I'm going to say that fine. Then this becomes 2 and then e to the 3x minus 2 all to the half. And then multiplied by e to the 3x take 2. And then on the numerator, I'm just going to have this here. So I'm just going to just copy this and then paste it here. So copy all of that there. And I'm going to paste this here and then bring it like this. So I'm here, right? So this is what we've got so far. Now remember, you've got to show that So let's just remind us of what the show that is. Okay, so we are here. And well, if I look at the denominator and I compare it to this denominator on the right, it's actually the same thing, isn't it? Because if you think about it, if I just get one more fraction bar like this here, then, well, the 2 is fine. And then we've got e to the 3x take 2 to the half, and then e to the 3x take 2, right? And that's just to the power of 1, isn't it? I need to just add the powers together to simplify this. So that will be e to the 3x take 2, and then 1 half plus 1 is 3 over 2. So we've actually got the denominator in the show that, which is fantastic. So that means that we're done with the denominator, and we just need to work with the numerator and eventually see if we get what they want on the numerator in the show that. So let me just paste this here. Let me just make sure I have everything here. I think I'm missing a bracket actually. Let me just see. Yeah, I'm missing a bracket, I think, when I copied it. So there should be a bracket right here. There should be a bracket right here, isn't it? There should be one here and here. Okay. Yeah, that's fine. Perfect. So this is where we're at. And I think we're nearly done. So let's have a look and see what we've got here. Now, what I need to do is I'm going to expand this here. I'm going to expand this bracket here. So I'm just going to copy this. I'm going to copy this and bring this here. So if I copy this here, I'm going to get this. Let's expand this and see what we get. So what I'll do is I'll just I'll expand these first and then do the 2 after. So if I do this, it's going to be e to the 3x times by 7x e to the x. That's going to be 7x, and then e to the 3x and the x will make e to the 4x here. I'm going to put this 2 here because there's a 2 here. And then this one is going to be e to the 3x, and then I'm going to times this by 7e to the x. That will just give me plus 7, and then it will be e to the 4x. And then this one is going to give me minus 14x e to the x. And then this one will give me minus 14 e to the x, wouldn't it? And then we're taking away 21x e to the 4x. So remember, we're just looking at the numerator only now. Now, if I expand this, it's going to give me 14x e to the 4x, 14x e to the 4x, plus 14 e to the 4x, and then minus 28x e to the x, right? And then this is going to give me minus 28 e to the x, and then we're taking away the 21x e to the 4x. So we're here, right? Okay. Now, is there anything I can simplify before we continue? Now, what I can see actually is that I've got 14x e to the 4x here, and I've also got a minus 21 e to the 4x here. So those two can actually simplify because they're like terms, aren't they? So it's just 14 take 21, which is a negative 7, isn't it? So I have negative 7, and then I'm going to have x e to the 4x here. So these two terms are exactly the same. And then what I'm gonna do is, because I don't like starting with negative terms in my lineup, I'm gonna do this 14e to the x. I'm gonna bring this here. So 14e to the 4x here, and then I'm gonna have the minus 28x e to the x, and then minus 28 e to the x, like this. Now remember, this is a show that question. Let us just remind ourselves of the show that. So remember, the numerator is done. The numerator is done. We're just looking at the denominator is done. The denominator we did a long time ago. The numerator is what we're left with. So we're just going to do this here. Going to do this here. And yeah, so this is what we're at, right? So if I compare the numerators now, what do we need to do? Well, it says that we need to take out 7e to the x, don't we? Because the show that has 7e to the x. So what you can do from here is let's try and take out 7e to the x and see what happens. So if I take out 7e to the x out of every single term, what will that give me? Well, for this one, it will give me a 2e to the 3x, that's for sure. And then if I take it out from this one, it will give me an x e to the 3x, wouldn't it? Definitely give me that. And if I take it from these two terms here, well, it's going to be, I've got minus 28. If I take out 7, it's going to be minus 4. And then I need an x here, don't I? So that will just be minus 4x. That's fine. And then minus 28 e to the x. If I take out 7 e to the x, that will just leave me with minus 4. So I get this on the numerator. So let me just, oops. let me just bring this bracket closer. So this is where we're at, right? Now, that's perfect because we were able to do that. Now, if I look at the show that, there's also a further factorization. Apparently, we could take out e to the 3x, and we can do that actually. So I'll do this here. So we're gonna get 7e to the x, and then we're going to take a bracket here. And then if I take out e to the 3x of these two terms, it'll be e to the 3x like this, and it'll be 2 take x like this, and then we've got minus 4x minus 4. And if I compare this numerator with what the numerator in the show that, it's in the exact same format. So we're pretty much done. So what I'm going to do now is I'm just going to bring back my numerator. So I'm going to write this one more time. So it's going to be 7e to the x, and then it's going to be e to the 3x, and then 2 take x. And then I've got minus 4x, and then minus 4. And then on the denominator, remember we showed that we got 2 bracket e to the 3x take 2 to the 3 over 2, which is exactly what we've got here. So I'm just going to say we've got 2 and then bracket e to the 3x take 2 and then to the 3 over 2. And this is exactly the same format that we've got. So we're pretty much done. And then obviously we've got ax and b where a and b were constants to be found. We can see quite clearly here that our a would be -4 and our b would also be -4. So we're done. And yeah, that was 5 marks. So yeah, this was quite a long question. It takes a lot of working out. It's 5 marks. I definitely feel it should be a lot more marks for sure because there's a lot of steps here. And yeah, I tried to make it as concise as possible, but so that you guys understand it. So yeah, it was quite long, but apologies for that. But let me know what your thoughts are in the comment with this question. Anyways, that's part A done. Okay, so part B says, hence show that the x coordinate of the turning points of the curve are solutions of the equation x is equal to 2e to the 3x take 4 divided by e to the 3x plus 4 for 2 marks. Okay, so what I'm going to do, so I'm just going to screenshot part B just so we don't have to keep going up and down. And let's just put it under part A. So put in this here. This is part B, right? Now let's read it again. We need to find the x coordinates of the turning point. Now remember, the turning point of a curve is just a synonym for stationary point, for maximum point, minimum point, and that is where your derivative is equal to 0, isn't it? So from here, I can see that I will need to set f dash of x equal to 0. And we can do that because in part A, we actually figured out what f dash of x was, wasn't it? It was this expression here. So what I'm going to do is let me copy this expression here and then paste it underneath. So paste it here and then we'll just do it. So I've got this here and let me grab this part and do it here. So this is our function here and we need to set this equal to 0, don't we? This is our f dash of x, right? So doing this will give us f dash of x. This is equal to 0, right? So to solve this, well, we've got a fraction and it's equal to 0. All that means is that you're just going to set your numerator equal to 0. That is the only time you can solve a fraction equal to 0. The numerator must be 0. The denominator can't be. Yeah. So all you're going to do here is just say, fine. Well, I've got a 7e to the x, and then e to the 3x, and then I've got 2 take x, and then minus 4x minus 4. This is equal to 0. This is what we're solving, right? Now, when we are here, if I have a look at this, I can see that I've got a factor here of 7e to the x, and I've got a factor here in the bracket. Now, the only way this can equal 0 is if either this is 0 or if this is 0. Now, with the first one, 7e to the x can't equal 0, right? Because we know from the exponential graph, it looks like this has an asymptote on the x-axis. So this definitely can't equal 0. There are no solutions here, meaning that our answer has to come from here. So what that means is we need to solve e to the 3x and then 2 take x, and then minus 4x minus 4 is equal to 0. So what I'm going to do is let me copy this here and then put this on the page below just so we can finish it off. So got this here. Now remember, it's a show that question. So always, always, always have in mind what it is they want you to show. So this is what they want us to show. Let's get that too. And then just compare with the algebra, right? So let us put this here. Okay, so this is what we need to get to. So let me just make this a bit smaller. All right. So what I would do first is I would definitely expand that bracket. So if I do that, that will give me a 2e to the 3x, take x e to the 3x, and then minus 4x minus 4, and this is equal to 0. Now, when I look at this and I compare it to my show that, well, I know I need to get a 2e to the 3x minus 4 somewhere. And if I compare with what I've got, I can see that I've got a 2e to the 3x here. And I've also got a minus 4 in the end. So I actually have that, right? And for me, because I have that, I would want to isolate those two green terms. And that would mean that I would want to move these two terms in the middle to the other side. And if I do that, that will leave me with 2e to the 3x minus 4. And then this is equal to, both of these terms are negative, so they're going to become positive on the right. So x e to the 3x and then add 4x. So we are here. And this is good progress because we have the numerator. Now we need to divide it by something. And we know how this works when we're trying to make something the subject of the formula. We can see that we have a common factor of x in both terms, don't we? That means we can take it out. So I have an x here, and then I have e to the 3x plus 4. And then on the left, I still have the 2e to the 3x, take 4. And then as we can see now, the divisor in our show that is exactly the bracket that we've just found by factorizing. So all we need to do now is just divide. So therefore we can say we've got 2e to the 3x take 4, and then divide this by e to the 3x plus 4, and then this is equal to x. So we've got what they wanted in part B. So that's done. That's 2 marks. Now let's go to part C. So let's have a read of it. Part C is right here. Right here. It says the equation x is equal to 2e to the 3x take 4 over e to the 3x plus 4 has two positive roots, alpha and beta, where beta is greater than alpha. A student uses the iteration formula xn plus 1 is equal to 2e to the 3x xn take 4 over e to the 3x n plus 4 in an attempt to find approximations for alpha and beta. Diagram 1 shows a plot of part of the curve of equation y equals 2e to the 3x take 4 over e to the 3x plus 4 and part of the line with equation y equals x. Using diagram 1 on page 42, draw a staircase diagram to show that the iteration formula starting with x1 is equal to 1 can be used to find an approximation for beta. Okay, so let us screenshot this part and then let's go to page 41 to see where the diagram is. So yeah, so this is where we are at. This is the diagram that they're talking about. We've got this question here. Let me just zoom in a bit. Okay, so remember, we need to draw a staircase diagram, right? Now, remember when you're doing these types of questions, you can either get two types of convergence, right? Whether it's a staircase or a cobweb. Now, in this case, we know that we're drawing a staircase, but even if you didn't know, remember what you should always know is when you're trying to draw the convergence in these types of diagrams, is you start from your value, you go to your curve and then to your line. Your curve, line, curve, line, curve, line, and then the pattern will reveal itself, whether it's a staircase or a cobweb. So we know that we're starting with x1 is 1. So we're going to go to our curve first. So our curve is right here. We hit our curve, and then we're going to go to our line, which is right here. This, and now we've hit our line. We're going to go back up to our curve, and then we're going to go to our line. And as you can see, we've got a lovely staircase here. And as we can see, this actually converges to our root of beta. So this here will give you the 1 mark in the exam. And that's pretty much it. So that is done. Now let's get the next question up. Let's see. So we've done part B, we've done part C. Part D says, use the iteration formula with x1 is equal to 1 to find to 3dp the value of x2 and the value of beta. Okay, so let's do that. Let me screenshot this too, so we don't have to keep going up and down. Let me get the iteration formula as well. So let me put this here. Put this here. This is our question. And the iteration formula we can get from here. This is the iteration formula. So let's get these two. Okay. So we've got these here, right? So iteration formula. So this is pretty easy, right? All you're going to do for part D, part I, you're just going to plug in x equals 1, isn't it? We know how this works. So let's get our calculator. And let's see. So get our calculator here. Move this over here. And then what we're going to do is we're going to set one equal to put one equals to get our answer, and then what you're going to do is you're just going to put this formula in, aren't you? So it's going to be get a fraction bar. It's going to be 2 and then e to the 3 and then answer like this, and then we're going to minus 4 and then divided by e to the 3 answer and then plus 4. And let's just double check that this is all written correctly before I click equals. We get 2e to the 3 answer minus 4. Yeah, that's fine. So I'm going to click equals and I get this number here. And this is our x2, isn't it? And they wanted it to 3 decimal places. So that means that x2 will equal, and then what is that to 3dp? That's 502, isn't it? So it'll be 1.502. So that's done, x2. And beta is the actual root. And remember, to find the actual root, remember this converges we saw from the staircase diagram. So all you're going to do in this case is you're just going to keep kicking, you're going to keep clicking equals, right? And see what your root converges to. So let me do this here. This will keep clicking equals and it'll be getting these here, clicking equals, and then it terminates here, right? And we need this to 3 decimal places. So this is our root here. So we're going to say beta is going to equal that to 3dp. And this is going to be 968, isn't it? So it'll be beta is equal to 1.968. And that's that for part D. So we're nearly done. We need to do part E now. Let me get it. Let's see. Okay. Now part E says, using a suitable interval and a suitable function that should be stated, show that alpha is equal to 0.432 to 3 decimal places. Okay, so remember, alpha is the other root. It's the root that is smaller than beta, right? So whenever you're doing these types of questions, right? Let me just put these here. Then let's get everything that we know or that we need, right? So remember from our diagram, we have the line, which they told us is y equals x, and the curve, which was this one here. Yeah. So what we're going to do, let us get that piece of information and let's just finish this question off. So get this here. Okay. So I think we've got all of the information we need to finish off the question now. So I'm just going to paste this here. Okay. So whenever you're trying to show that a root is approximately equal to some value, right? All you want to do is just get the boundary points, right? So for example, we've got the value of 0.432. And what I'm going to do is I'm just going to draw a little horizontal line like this here. So I've got 0.432, 0.432. And what you want to do is figure out the upper and lower bound. So what values would round to this? And obviously that would be quite clearly 0.4315 and 0.4325. And then what you have is that you're going to have some function and you're going to plug in your values here. You're going to plug in f of 0.4315. You're going to plug in f of 0.4325. And what you should hope when you plug these in is that this here will be less than 0. This will be greater than 0. And that would mean that, well, if that's the case, that means that this here would have to pass through 0, isn't it? Yeah. Obviously, they have to be continuous and so on and so forth. But that is the overall aim. Now, they said that we need to, a suitable function should be stated. Now, we are solving the solutions or the points of intersection between y equals x and this graph here, right? So what you'd want to do is say, okay, well, fine. Well, to get a suitable function, if I make these equal to each other, e to the 3x take 4 over e to the 3x plus 4, like this, and then this is equal to x here. Now remember, the solutions are from this equation. If I move the x over to the other side, I've got 2e to the 3x minus 4 over e to the 3x plus 4, and I'm going to take x, right? And this is equal to 0. Now, this is quite good because the right hand side is equal to 0, I can just plug in my values of x here, my upper and lower bound into this, and hopefully I should get less than 0 on one side and greater than 0 on the other. So what you're going to say is that your function, the function that should be stated, I'll use h of x because we've already used f. H of x will equal this function here, 2e to the 3x take 4 over e to the 3x plus 4, and then take x. Now, what you're going to do is you're just going to plug in your value. So you're gonna plug in you're gonna find h of 0.4315, figure that out, and you're gonna plug in h of 0.4325, figure that out, and hopefully you get a change of sign. So let's go ahead and do that, right? So for the first one, what do I have here? So let me move this here. So I'm using this function here on the left. So what I'm gonna do is I'm gonna plug in the 0.4315 first. So what I'm gonna delete these. I'm gonna delete these because I already have it. All I need to do now is just take away the x, isn't it? So I'm gonna plug in 0.4315 like this, and then I'm gonna plug in 0.4315 here, and then I'm gonna take away 0.4315, 0.4315. Let me just double check that's fine. Yeah, that looks good to me. That looks good to me. And I'm gonna click equals, and then this gives me this number here, isn't it? 0.000297, blah blah blah. It's negative, isn't it? So therefore we've got negative 0.0000, and then it's 2975, 2975, 2975. That is the first one, right? Now we're gonna plug in the upper bound. So I'll do this here actually, and this will give me. I'm just gonna change all of the ones to two. So 2 here. I'm gonna change this to a 2 here. 2 here, and I'm going to change this to a 2 here, and hopefully this should be positive. Let me just double check this is fine before I click equals. It looks good to me, and then I get this number here, which is positive, which is good, and that is how many? That's 0.000. Now what's the number again? 94795. 94795. Okay, and what we can see here is that we've got a change of sign. So what you need to do is you've plugged in your values. Now to get your second mark right, you just have to state a couple of things. First thing you need to state is that you've got a change of sign. That's very important. And as well as that, you need to make sure your function is continuous, right? Which this would be continuous. The only potential issues would be maybe the denominator, but the denominator is e to the 3x plus 4. That is always positive. This is never going to be 0. So this is definitely always continuous. So I'm going to write h of x is continuous, continuous. And the last bullet point is just to state, well, therefore, that would mean that alpha would be 0.432 to 3 dp. And that would be your answer for part E. Yeah, part E. And yeah, that's pretty much it. So yeah, that's paper 1 done. Some tricky questions, especially this last one. But yeah, that's all done. So hope you found that beneficial. Hi guys, Daniel here. Hope you're doing well. So yeah, we've made it to the end of paper 1. I hope you guys found the video beneficial and you were able to get the answers that you needed for certain questions and it all makes sense. And yeah, if you found it beneficial, then feel free to subscribe, like, and share. If by the time you're watching this, paper 2 and paper 3 isn't out yet, don't worry, it will be out very, very soon. I'll be getting on that. So yeah, again, thank you for watching and be sure to like, comment, subscribe, and I'll see you for paper 2 and paper 3. Take care. Bye bye.